All right, everybody, what is up on this beautiful Monday? What a beautiful Monday it is over here in the Chicagoland region. Very hot, very, very hot, but awesome to say the least. Beautiful day. Yes, so um, very awesome. So great to see all of you in here. Great to get this started today. Get the week off started very well. So very thankful for all of you. Just so thankful. So give it time for people to pile in here. Making my way, getting close to 3,300 subscribers. So great to see you all in here. Great to see everybody. Let's all see. Everybody check in, please. Let me know how you are doing today, tonight. It's a great night. Like I said over here, very great. Great to see. Um, Great to see you, Diesel. Great to see you, Libby. Great to see you, Angela. Great to see you, Sonia. You all are awesome. You guys are the best. So, yes, welcome in, Libby. Welcome in, Sonia. Welcome in, Angela. Welcome in, who else we got here? Welcome in, Lisa. All of you are guys are awesome. So tonight we are going to take a little bit of a deep dive into earthquakes, and I know that earthquakes have been in the news lately. So just kind of want to give an overview of that and give some cool facts about earthquakes and some top records for earthquakes. So welcome in, Lonnie. Welcome in, Omni. Welcome in, all of you. Welcome in, everybody on Twitch. Welcome everybody in on Kick. Welcome in everybody on Facebook and everybody on YouTube. You guys are awesome. You guys are so very awesome. So, just again, great to see all of you. Again, hope you guys are having a great Monday. It's a beautiful Monday over here in Chicago land region. Um, Looking outside my window right now, and it's nothing but blue skies and very nice weather. So a lot of that. So very great stuff. Very great stuff from all of you. Hope you guys had a great weekend as well. And everything. So um, let me know how your weekend was. Hope you guys had a great thing. So definitely, definitely am very, very um, thankful and blessed to teach all of you, to be here with all of you. And again, I hope you guys are all having a great time here. So we'll get started here in about 5 to 10 minutes. Let people roll in here, just kind of get things going and get things started. But yeah, so again, I hope everybody's having a great time. Hopefully, everybody again is having a great Monday. Uh, so, so yes. But again, great to see everybody who's in here. Great to see everybody in the chat. Please make sure that you are chatting. Please make sure to, um, say hello in the chat if you are lurking or if you are just watching. But please say hello and um, mingle and talk with everybody. So Sonia says, John Boy, thank you for covering earthquakes. You're welcome. And we're going to get kind of deep into earthquakes. We're going to get a little scientific on it. Hopefully not to bore you guys too much on it, but we will get in there. So Very thankful for that. So, but yes, we will get a little bit. We'll get into, um, we'll get a little deep into earthquakes there. So, um, yes, Omni, that is correct. Yes, they just had one. Yes. Speaking of, yes, Lake Michigan did just have an earthquake not too long ago, a couple of days back, 2.9, but nonetheless, um, still an earthquake in Lake Michigan. So, but yes, so yeah, so we're gonna look at again the science of earthquakes. We're gonna dig a little deep into them, and then we're going to look at kind of where they happen at the most, why they happen, and there's some really cool facts about earthquakes that maybe you guys don't know, and then we'll also take a look at some cool, kind of the largest, look at the largest earthquakes that have ever been recorded in recorded history. So it's gonna be a fun topic. Gonna be a great topic to look at that and talk about that. And so yes, so very thankful, very blessed for all of you for being here again. So very thankful for that. So again, we'll get started here in about 7 minutes or so. Uh, Again, grateful for all of you. For all of you for being here. Update on myself. I am very close to becoming a YouTube partner. I only need not very many more watch hours. So not too many more watch hours to go. And then I will hit the threshold to become a YouTube partner, and then I can apply for that. So, so very good on that. So, so yeah, so very thankful for that. Thank you, Lisa, for chiming in off a kick. So thank you so much for that. So, um, so yes, so very thankful. So very thankful for um, getting super close to being able to apply for YouTube partnership. So again, not too many watch hours away. Only about 400 watch hours away. So 400 is not that much to go. So about 400 watch hours away, and then I'll be able to apply. So again, very thankful for all of you. Thankful for everybody on Twitch. Thankful for everybody on YouTube. Thank you to everybody on Kick. Thank you to everybody on Facebook. Thank you to all of my supporters and for all of my encouragers. For all of my brothers and sisters in Christ. Thank you. I wouldn't be able to do this without you guys because you guys are the best. You guys really are the best. You guys are just awesome. So, but yes, very thankful. It's going to be a great topic again. It's going to be a great topic to discuss, great topic to go over, have some great chats about. And we pretty much know the destruction of what happens with earthquakes, and we know the things that can come from them. But it's always great to learn more and great to um, deep dive into that. So, very thankful, very thankful for that. So, when it comes to that, so again, hope you guys are all having a great time. Hope you guys are all having a great night. If you are new here, please like, please subscribe. All right, and even if you're not new here, please like. I really would appreciate that. If you would like the stream, please. It helps me out, helps the algorithm out, helps everything out. But yes, but if you are new here, please like, please subscribe, please share. Um, Thank you for being here. So if you do like my content, I appreciate that. And even if you do not like my content, I appreciate you being here and I appreciate you checking in. So definitely am appreciative of that as well. So very thankful. Again, very blessed. But please like, please subscribe, please chat. Please be vocal in the chat. Please chat away. Please make yourself known. Please. And again, if you have any, just please chat and mingle and things of that nature. So very thankful for that. So we will get started here. We'll get started here in 4 minutes. So it would be 6:40, about 6:40 my time. We'll get started 7:40 Eastern, 5:40 Mountain, and 4:40 Pacific. So about 4 minutes, and then we'll kick off into tonight's session, into tonight's severe weather lab session and seminar. So very thankful to teach all of you. Very thankful that you guys are all here. Very thankful that you guys all trust me and that you guys all um, respect me enough to listen to what I have to say. And I really do appreciate that. So when it comes to that, thank you, Lisa, for I believe you just hearted on. Thank you, Lisa, from commenting from Twitch. Thank you so much, Lisa. Appreciate that. Thank you very, very much. Highly, highly appreciative of that. Thank you so much. So, when it comes to that, Lisa, you are awesome. So very great stuff. Very great stuff. Obviously, great stuff. Brother John McKinney has a lot of great stuff going on. Him moving to Weatherfront, him doing, just some great moves and, some great business moves. And so very happy for him. Very thankful that he's making those great business moves to help him and position him for future, for not just now, but in the future as well. So, continuing his his partnership with Max Velocity and moving to Weatherfront is going to be a great sign of just great things. Great way to scale himself and great way to scale his storm chasing business. So very thankful for Brother John McKinney to have that opportunity and for him to do that. So, but yes, very thankful for brother John, Pastor John McKinney's again for his opportunity to go to Weatherfront and to continue with Max Velocity as well. So it's a great partnership to work with Max. So I'm again very thankful and very very happy for Pastor John there. So yes, and if you guys do not know who Pastor John is or who Pastor John McKinney is, you can just type in ! Papa John and his YouTube channel link will pop up, and you can click on his link, and you can also please subscribe to him if you have not. So that will pop up a link, and you guys can be able to subscribe to Pastor John McKinney if you have not already. So definitely check him out and give him a subscription or give him a subscribe and a like, a follow, and everything else that goes into social media. So when it comes to that, so but great stuff. So looks like we got Debbie in here now. Great to see you, Debbie. Such a great supporter, such a great encourager, everything. So great to see you in, Debbie. Very awesome. So you guys are amazing. So it is now 6:40 my time. So we will get the party started. So as always, before I start any of my sessions or any of my weather lab seminars, I have to always, first of all, give honor, give glory, and give thanks to my Lord and Savior, Jesus Christ, for allowing me to do this, for allowing me to be here, for everything, for blessing me. So just extremely gracious, extremely grateful for his love and for his mercy and for his grace. Because again, without him, none of this is possible. So again, always give glory, honor, and praise to Jesus Christ, my personal Savior. And again, if you do not know Jesus on a personal level, please reach out to me. Please reach out to people in the chat so we can help guide you in the right direction so you can get to know Jesus on a personal level so he can become your Lord and Savior. So, very, very awesome. But again, always all the glory, all the honor, and all of the praise always goes to Jesus first and foremost. So, very thankful for everything. So, thankful for his graciousness, thankful for his kindness, thankful for his love, thankful for his mercy, thankful for his grace, thankful for everything that he is and that he stands for. So again and again, I will always be unashamed and unapologetic in my love and my boldness for Jesus. So again, thank you very much and very grateful to Jesus for everything. So that being said, we are going to start a great session on earthquakes. And again, we're going to get a little bit scientific. We're going to get a little bit into a little bit of the rubbing of the earth and the plates, and we'll talk a little bit about that and slips and faults and all the good stuff that goes into earthquakes and how they're measured, how strong they are, and again some cool facts. We'll look into the 20 largest earthquakes that have ever been recorded, and we'll talk a little bit more in depth about that. So great stuff, and might be some stuff that you already know, which is awesome. So thankful that you are here, but it might be some stuff that you do not know about as well. So without further ado, let's get the party started. So, right from the beginning, what is an earthquake? Well, we basically have all heard an earthquake, but can we define what an earthquake is? So, great information here, and the majority of information I'm going to be using here is from the USGS website. So, that is the United States Geological Survey website. So, they are the authority on earthquakes. So, if you need to know anything and everything about earthquakes, always utilize the USGS website. They have such great things. They'll teach you everything from monitoring, education, maps, you name it. USGS has it all. So what is an earthquake? So, what is the definition of an earthquake? So, an earthquake is what happens when two blocks of the earth suddenly slip past one another. So, we'll get into how they slip past each other and the ways that there's three different types of earthquake movements that we'll get into. So when it comes to that, so the surface where they slip is called the fault or fault plane. So when they slip past each other, so whether they fall down this way or they separate this way, that is called the fault or the fault plane. So again, an earthquake is what happens when two blocks of the earth suddenly slip past one another. And again, we'll kind of get more into what that slip means. So they can fall upward, they can move upward, it can move downward, and they can also separate as well. But again, we'll talk a little bit more in depth of that. The location below the Earth's surface where the earthquake starts. So remember, this is below the surface. So where the earthquake starts below the surface, this is called the hypocenter. So this is a term that's not really used in the media or that's used out there a lot. A lot of times people won't talk about the hypocenter. But the hypocenter is where the earthquake starts below the surface. So below the surface, it's called the hypocenter. And the location directly above the surface where the earthquake happens or starts at, that's called the epicenter or the epicenter. So that is what's used a lot in the media. That is what is used that you might hear is called the epicenter. Where is the epicenter, or where was the epicenter of the earthquake? So remember, the epicenter is directly above the surface. The hypocenter is directly below the surface. So epicenter is what usually always gets talked about, though. That is what is um, usually what's out there and talked about a lot in the media and things of that nature. So again, there's a hypocenter and there is the epicenter. Those are the two things. So again, just to backtrack a little bit again, just for a second, the surface where they slip is called the fault, and we'll talk about faults and we'll talk about things like that when it comes to that. So sometimes an earthquake has foreshocks. So sometimes there'll be little tremors or little shocks that'll come out, and you'll feel it, maybe feel it, a little bit feel it before the big one comes. So um, it's almost like a foretelling sign. Um, so think of it kind of like a little storm before, let's say, a big storm comes along. So it's almost like foretelling the future. So you might get a little shock, and then the big one might come not too long after that. So there are foreshocks, because a lot of people have heard aftershocks, but a lot of times people forget about what the foreshocks that can happen. So again, sometimes earthquakes, not all the time, but sometimes earthquakes do have foreshocks. They are smaller earthquakes. Earthquakes are also called tremors. So if you ever heard tremors, that's just an earthquake as well, just another term used for earthquake. So if you hear tremor, it means the same thing. Uh, these are smaller earthquakes that happen in the same place as a larger earthquake that follows. So let's say if Los Angeles maybe one day had a 2.0 earthquake, and then a couple of days later they got like a 6.0 or something like that, or something else. So they would have had a foreshock before the big boy came down the line. So um, very thankful for that. Very thankful for you, Lisa, again, for checking in on Kick. Thank you so much. Definitely appreciate that. So, again, foreshocks can prelude and foretell possible larger earthquakes coming down in the near future. So, scientists can't tell that an earthquake is a foreshock until the larger earthquake happens. So, again, it's not known, but it is foretelling in a sense that it's saying, well, maybe, possibly, a bigger one might come down the line, but you just never know, because it could be a 2.0 and nothing maybe might not ever come from it, or it might be it might be a 2.0, it might be a 1.5, it might be whatever it is, and then a couple of days later there might be a 5.5 or a 6.0 or something like that. So you just never know. But again, if there is a big one after it, that small one was a foretelling um, um, sign. So great stuff there. Great stuff. If you guys are still with me, great stuff. If you guys are learning, thumbs up. If you guys are all having fun still on this beautiful Monday night, so let me know there. So definitely appreciate that. And Debbie's got a thumbs up. Thank you, Debbie. Appreciate that. When it comes to that, so thank you, Lisa. Appreciate that. So great to have you all still in here, and hopefully keep you all entertained here with some earthquakes here. So if we look at the picture here, show it here a little bit. So the picture is going to show kind of the fault. It's going to show the fault plane here. Let me scroll to where we can see it here. And then so think about if these two pieces of earth, where the earth's crust, the mantle, were all together here, and then think about if this one right here slipped down. So if this slipped down, so think about this picture here. What this picture is showing, it is showing the earth moving down in this way. So if it moved this way, you get the hypocenter here, right here in the middle, and then right above it would be the epicenter right here. But again, this would be an earthquake because of the slipping. This would be a fault because it slipped down past each other. They slipped down apart from each other. So that is kind of giving you a little bit of a visual. There's a better visual that is coming up here in a little bit, but that just gives you a little bit of a visual there. So So great to see you all again here. So very awesome there. So again, the largest main earthquake is called the main shock. So there could possibly be four shocks before the main shock, but it could not. You just never know. There's it's kind of like it's kind of like trying to predict tornadoes, right? It's something that can't be done. So you just never know that if a foreshock might come before the main shock. So the main shock is what we always hear about. That's like the main thing, right? So whether that is a 5.0, whether that's a 6.0, whatever it may be, the main shock is what we still hear about, is what we always hear about, because that is what causes the most damage. That is what causes the most damage to structure. Unfortunately, loss of life, loss of property, loss of livestock, loss of things of that nature. So the main shock is what we always hear about. And then, but main shocks always, and this is definitive. Main shocks always have aftershocks after them. So there will be an aftershock in a smaller form, but there will be an aftershock after the main shock. So after the main shock wears out and it starts to fizzle out and everything, it will have a aftershock to still release the energy that's still built up there. That is still built up there in the Earth's crust, core, mantle in that region. So again, what an earthquake is doing, it's releasing energy, and we will get into that. So that is what's happening there. So when it comes to that, so these smaller earthquakes that occur afterwards in the same place as the main shock, depending on the size of the main shock, aftershocks can continue for weeks, months, or even years after the main shock. So could you imagine getting hit by like a 7.0, which is considered a major earthquake, and then 10 months later, 14 months later, you're still getting hit by like 3.0s or 3.5s and 3.2s? So you can still get aftershocks even years after the big main shock. So I don't think that unless you really understand, unless you are a follower of earthquakes and understand earthquakes, uh, a lot of people don't know or nor understand that you can get aftershocks for years after the main shock. So again, very wild to know, but yes, it is not uncommon for that to happen. So yes, very very just it's just kind of wild to even think about. And so again, it's very wild to think about that. Even years later, you could still be getting aftershocks from the main shock that you received. But again, not all are the same, but it can last for years for the aftershocks. So that's basically the big overview of what an earthquake is. It's basically the Earth crust moving in it, slipping past each other. Um, they're all slipping, moving, whatever term you want to use there. It slips past. It falls out of place. Whatever you want to call it. A bunch of different terminology there that's used throughout. Um, and they suddenly slip past one another, and then where they slip past is called the fault or fault plane. So again, that is what's happening with an earthquake. Again, it is the movement of the earth moving past each other. So when it comes to that, so what causes earthquakes and where do they happen? Um, so again, where are the earthquakes taking place at, and where do they happen? Again, what causes them? So the earth has four major layers, right? So if we're looking at the earth, we're looking at the inner core, the outer core, the mantle, and the crust. The crust and the top of the mantle make up a thin skin on the surface of our planet. But this skin is not all in one piece. It is made up of many pieces like a puzzle covering the surface of the earth. So, not only that, but these puzzle pieces keep slowly moving around, sliding past one another and bumping into each other. We call these puzzle pieces tectonic plates. So, if you hear the word tectonic plates, that's exactly what they're talking about. They're talking about puzzle pieces that are moving all the time in the earth. And we don't feel them, obviously, until they slip past each other, until something happens. So, again, so that's what a tectonic plate is. I'm sure you probably have heard the term tectonic plate, and we're gonna look at a picture here of a lot of the plates that are all over the world. But I'm sure you've probably heard the word tectonic plate. But again, that's what that is. It is a puzzle piece that is moving all the time. So, and the edges of the plates are called the plate boundaries. So they are boundaries, just like a warm front and a cold front, a trough, all these other outflow boundaries, just to name different boundaries when it comes to um, other types of weather. So there are boundaries as well that separate plates from plates. So again, tectonic plates. So when you hear tectonic plates, it is a moving puzzle piece that's moving all the time when it comes to that. So the plate boundaries are made up of many faults, lots of faults. So, and most of the earthquakes around the world occur on these faults. And the big one here that we always hear about in the United States is a San Andreas fault. That is the biggest one because that is part of the Ring of Fire, which we will talk a little bit more about what the Ring of Fire is and how that pertains to earthquakes. So, since the edges of the plates are rough, they get stuck while the rest of the plates keep moving. So what's happening is that the edges of the plates are really, really tough. They're rough, they're tough, they're jagged, they're all of that good stuff that goes into that. So what's happening? They get stuck. They get stuck in other pieces of the earth, inside of other pieces, but the other stuff around them is moving. So what's that going to do is that as they get stuck because they're rough and jagged and everything else. So then what happens is finally when the plate has moved far enough, the edges unstick on one of the faults, and there is an earthquake. So what happens is they get stuck. It gets moved around. They're being moved around, and then once they get unstuck, then that's when an earthquake happens. So again, they're being stuck to each other. The tectonic plate's still moving around them because the edges are stuck to another edge of one another. Once enough force moves, once enough force unsticks one of them, bam, then that's when an earthquake happens. So that is what's happening in the earth underneath the surface that we cannot see that's going on. That is how, again, that is what causes earthquakes, and that is where they happen at. So again, tectonic plates. If you hear tectonic plates, those are the moving puzzle pieces. And again, the edges of the plates, where the boundaries are formed at, the edges of the plates are rough. They get stuck while the rest of the plate keeps moving. And then once they get unstuck by all that force, bam, all that force takes it, moves it, and now you got all this amount of energy that just moved, and now we have an earthquake on our hands because the energy has to be released. And what we feel is the earthquake is the energy that's being dispelled from that. So again, great picture here about the crust, mantle, and the core, solid core, liquid core. So that goes into that. So look at this great picture here. This great picture is going to show the plates that are around the world. As you can see, North American plate. I won't go through all these, but North American plate, Philippine plate, Australian plate, African plate, Eurasian plate. These plates are everywhere across the whole world. So, again, this is how they are mapped out for the plates when it comes to that. So, uh, but again, plates, plates, and plates. They're everywhere. So, why does the earth shake when there is an earthquake? So, again, I just kind of described it a little bit, but we'll talk about why the earth is going to shake for, why it has to shake for when there is an earthquake. So, while the edges of faults are stuck together and the rest of the block is moving, the energy that would normally cause the blocks to slide past one another is being stored up. So again, these edges are stuck together. They're stuck together with each other. The rest of the plate is moving. So as the rest of the plate keeps moving, it's building up energy. So think about it. It's just taking on more and more and more and more energy. So it's kind of like when you shake up like a soda can or shake up something and it gets all the fizz and stuff in it and everything, and then once you pop open that lid, it just goes everywhere. Well, that's because you have energy stored inside of it from shaking that can. So um, for the gist of it, it's stored up energy that you use. So again, the plates are stuck together, the rough edges are stuck together, the rest of the plate is moving, storing up the energy. So when the force of the moving blocks finally overcomes the friction of the jagged edges of the fault and it unsticks, all that stored up energy is released. So again, that energy has nowhere to go. The energy that was been stored up with the plates moving and the edges that were stuck together, and now the edges have now unstuck and slid past one another. Now that energy has nowhere else to go but to dispel, and that's when the earthquake happens. That's what we start to feel. So the energy radiates outward from the fault in all directions in the form of seismic waves. So again, seismic waves. So again, and we'll get into it. We'll talk a little bit how earthquakes are recorded. That's in the next section, and we'll talk a little bit more about seismographs and things of that nature. But the energy radiates outward in all directions when it comes to that. So Libby says, isn't it amazing that it feels like the earth is shaking, but God keeps us on our axis? Yes. Great point, Libby. Love that point. Thank you so much. Very, very well said. Diesel Weather says, sounds like the line at Golden Corral sometimes. I think that might be referring to maybe the way that maybe I don't know, actually. I don't know what you're talking about there, Diesel. Let me know what you're talking about there, brother. I'd like to know that for sure. So, but nonetheless, thank you, Libby. Very, very, very much for that, Libby. Thank you. But nonetheless, yes, the energy radiates. So remember, the energy is going everywhere. It's not just going in one direction. It's going outward in all directions, 360 degrees. So if you were like to kind of like look down at it and it looked like a wave, it would look like a wave going out in all directions. So it's getting spread out in all directions. So again, it's not just moving north, it's not just moving south, it's not just moving in whatever direction. It's moving in a 360-degree all wave in all directions when it comes to that. So it's like ripples on a pond. So if you throw a rock into a pond, if you throw a rock into a lake or whatever it is, and you see the ripple effect of it, right? You can see how when as soon as the rock hits, the water disperses from the ripple effect. So all the energy that just came into the water, it disperses out. So that is what is happening as soon as an earthquake happens. It is dispersing energy out in all directions. So the seismic waves shake the earth as they move through it. And when the waves reach the earth's surface, they shake the ground and anything on it, like our homes and us. So again, so what's happening? Remember, it's a seismic wave. So just like it is, it's a wave, right? It's a wave spreading out. So what's happening here again is that the seismic waves shake the earth as they move through it. So the earth is already shaking below we can even feel it. The earth is already shaking. So, and when the waves reach the earth's surface, they shake the ground. That's when we start to feel it. And so they shake the ground and anything on it, like our homes and us. So again, it is a wave. It's a seismic wave that is going out. So great stuff. Thumbs up if you guys are still doing great. Y'all having fun, enjoying. Yes. So just please let me know there. Thank you. Let me see what Diesel says here. Diesel says, trying to get to the meat buffet line and all elbows rubbing like tectonic plates. Oh, okay. I got you. I got you. Awesome. Awesome. What else? What else? What else? I missed it. I missed. Let's see. Sorry, here real quick. Oh, trying to get to the meat buffet line and all elbows rubbing like tectonic plates. Something will eventually give. Yeah, it's been a while since I've been to a buffet, but I do remember. Yes, a lot of times it is kind of um, what you call it there, kind of arm to arm, elbow to elbow. So yes, definitely when it comes to that. So uh, great, great, great point out there. Great joke there, Diesel. Appreciate that, brother. So back on track here. Uh, how are earthquakes recorded? So earthquakes are recorded by issues called seismographs, because remember, it's a seismic wave that gets created and that moves out. So they are recorded by instruments called seismographs. The recording they make is called a seismogram, so that's how they read them, and it looks like they make little jiggly lines, and kind of looks like when like your if you ever had like a heart monitor hooked up, whatever, and your heart and shows your heartbeat and stuff like that. That's basically what is happening here in a nutshell. It's basically showing the heartbeat of the wave. It's basically when it looks at the seismogram, that's what it's doing, and that's what it kind of looks like when it comes to that. Uh, so the seismograph has a base that sets firmly in the ground and a heavy weight that hangs free. So again, the seismograph has a base that sets firmly in the ground and a heavy weight that hangs free. When an earthquake causes the ground to shake, the base of a seismograph shakes too, but the hanging weight does not. So let me say this again. When an earthquake causes the ground to shake, the base of the seismograph shakes too, but the hanging weight does not shake. So the hanging weight is just freely hanging there, but the base does shake. Instead, the spring or string that it is hanging from absorbs all the movement. The difference in position between the shaking part of the seismograph and the motionless part is what's recorded. So again, it gives you a great picture down here of what over here of what is going on, of what is happening. So seismograph. So that is what is used to record earthquakes. That is what's used, seismographs, when it comes to that. So again, it is called a seismograph because remember, the earthquake is spreading out in forms of seismic waves. So that's what a seismograph does essentially. That's basically the best breakdown of what a seismograph does when it comes to that. So how do scientists measure the size of earthquakes? So I think a lot of us have probably heard about this before, right? A magnitude, right? We probably heard the Richter scale. Oh, that was 8.0 on the Richter scale or 7.0 on the Richter scale. So we probably have heard that in media or whatever it may be. But again, scientists measure earthquakes in magnitude, and we will get to that. Also, intensity as well, which we will get into. So, how do scientists measure the size of earthquakes? Well, the size of an earthquake depends on the size of the fault. So, on the size of the slip and the amount of slip on the fault. But that's not something scientists can simply measure with a measuring tape since faults are many kilometers deep beneath the Earth's surface. So, how do they measure an earthquake? They use a seismogram, as we talked about, recordings made on the seismographs at the surface of the Earth to determine how large the earthquake was. And this is where it gets into the little bit of the lines. A short wiggly line that doesn't wiggle very much means a small earthquake. A long wiggly line that wiggles a lot means a large earthquake. The length of the wiggle depends on the size of the fault, and the size of the wiggle depends on the amount of the slip. So again, to talk about a little bit about the lines there, because the lines might be a little bit confusing again of what it happens, and it's a great graph right here which shows what's going on, the P and the S, which we'll talk about. There's a P wave and the S wave when it comes to that. So which we can get, which we will get into here. So when it comes, so again, just go over that briefly. A short wiggly line that doesn't wiggle very much means a small earthquake, but a long wiggly line that wiggles a lot means a large earthquake. So that's how they can decipher between a small earthquake and a large earthquake. That's what is used in the weather community. That's what is available. So again, so the length of the wiggle depends on the size of the fault, and the size of the wiggle depends on the amount of the slip. So again, that is what they are utilizing in order to measure the size of the earthquake. So the size of the earthquake is called magnitude. So now we're into magnitude. This is what we hear. 3.5 magnitude, 4.0 magnitude, 2.1 magnitude. This is what is used to define the size of the earthquake. There is one magnitude for each earthquake. Scientists also talk about the intensity of shaking from an earthquake, and this varies depending on where you are during the earthquake. So again, if you are close to the epicenter of the earthquake, the shaking is going to be more violent. If you are further away from the epicenter of where the earthquake happened, the shaking will not be as violent. But that does not mean that it wasn't a 7.0 or a 7.2 or whatever it may be. The closer you get to the epicenter of that earthquake, the more violent it's going to be. So just remind. So you could be in a large city, and let's just say you're in Chicago, and an earthquakes happen right downtown in Chicago. Well, the folks downtown are going to get an enormous rude awakening, but the folks in the suburbs, it's probably going to shake, but not quite as bad as it was downtown. Now, but still, the size of the earthquake, the magnitude does not change just because of what you felt. It still is rated whatever it is at the epicenter of that earthquake. So again, that's where that comes from. Closer to the epicenter, the more violent it's going to be. The further away from the epicenter is the less violent that it's going to be. So just remember that when it comes to earthquakes. So how can scientists tell where the earthquake happened? So this gets into the epicenter, hypocenter, as we talked about a little while ago. Seismographs come in handy for locating earthquakes seismograms come in handy for locating earthquakes too, and being able to see the P wave and the S wave is important. You learned how P and S waves each uh, shake the ground in different ways as they travel through it. P waves are also faster than S waves, and this fact is what allows us to tell whether an earth or an earthquake was. To understand how this works, let's compare P and S waves to lightning and thunder. So here is a great thing to learn about. So P and S waves are like lightning and thunder, which a lot of us know when we see storms, right? We see lightning and then we hear thunder. So yes. So so light travels faster than sound, which we know that's very very true. That is 100% true. So so during a thunderstorm, you will see the lightning and then you will hear the thunder. That is how it works. That's just the science of it. That's how it always works. If you are closer to the lightning, the thunder boom right under the lightning. I'm sorry. If you are if you are close to the lightning, the thunder will boom right after the lightning. But if you are far away from the lightning, you count several seconds before you hear the thunder. The further you are from the storm, the longer it will take between the lightning and thunder. And again, that's just natural. That's just true. That is just weather in and of itself. When it comes to that, so P waves, or remember, P waves are like lightning. So P waves are like lightning and S waves are like thunder. So the P waves travel faster and shake the ground where you are first. Then the S waves follow and shake the ground also. If you are close to the earthquake, the P and S wave will come one right after the other. But if you are far away, there will be more time between the two. So again, if you are near the epicenter, the P and S will come right after one right after another. And again, the epicenter is just like being right underneath a severe thunderstorm, and bam, the lightning hits, and then within not even a second or so, the thunder hits right after that. So you're basically at the epicenter of that thunderstorm. So that is what's going on here. That is the same concept of what's happening here. So when it comes to that, so by looking at the amount of time between the P and S waves on a seismogram, recorded on a seismograph, scientists can tell how far away the earthquake was from that location. However, they can't tell in what direction from the seismograph the earthquake was. So they can't tell you which direction it came from, but they can tell you how far an earthquake was away from that location. Only how far it was, as I mentioned. If they draw a circle on a map around the station where the radius of the circle is determined distance to the earthquake, they know that the earthquake lies somewhere on that circle, but where? So again, it's not really known. It's anyone's guess at that point. So again, they'll draw a circle and try to pinpoint and plot it out from there. But again, they'll get very close using the P and the S waves when it comes to that. So scientists then use a method called triangulation to determine exactly where the earthquake was. So again, without triangulation, you're not going to be able to find exactly where that earthquake happened at. So when it comes to that, so again, the P wave is like lightning. It's going to come first, and the S wave is like thunder. So it's P and S. So PS, right? Like PS, I have more to say, right? Like when we write letters or whatever it may be, right? So it's like PS. So P again is lightning, S is thunder. So, but the closer you are to the storm, I will just use storm as an analogy, or the closer you are to the epicenter, the P and S will happen pretty much almost simultaneously. Just like lightning and thunder almost happen simultaneously when we are at the epicenter of a storm that's just directly over our heads when it comes to that. So very great stuff. Very great analogy there to use with storms. So again, without triangulation, which we will get into, if they're just using the seismograph and things of that nature in a seismogram, they're only going to be able to point it out on a circle radius. But this is where triangulation comes in, and this helps pinpoint the epicenter of where the earthquake happened and the hypocenter. So scientists use a method called triangulation to determine exactly where the earthquake was. It is called triangulation because a triangle has three sides. So remember this. This is very, very important. Um, and it takes 3 seismographs to locate an earthquake. So again, plotting 3 different seismographs in order to create that triangulation. So this is what is going on here. This is what the geologists use. This is what scientists use when it comes to this, seismologists and things like that. So if you draw a circle on the map around 3 different seismographs, where the radius of each is a distance from that station to the earthquake, the intersection of those 3 circles is the epicenter. So that's how you get the epicenter of an earthquake. Again, if you draw a circle on a map around 3 different seismographs where the radius of each is the distance from that station to the earthquake, the intersection of those 3 circles, that's the epicenter of where that earthquake happened at. So again, that's how scientists use, that's how it is used to find exactly where that earthquake happened at. So that's where we can find the epicenter when it comes to that. So again, it's called triangulation. That is what is used to find the epicenter of an earthquake. So, can we predict earthquakes? Can scientists predict earthquakes? And just like tornadoes, the answer is no. No. And it's unlikely that we will ever be able to predict them. So, pretty much the answer is always going to be no. That we will not ever be able to predict earthquakes before they happen. It's just not possible with the tools we have, the data we have, with the resources we have, with the moving of the plates. It's just an unpredictability that's there. So again, just like tornadoes cannot predict earthquakes. So again, that is God's power at work, that we cannot predict a lot of things that are out there. So again, that's is going on. So no, and it's unlikely that we will ever be able to predict them. Scientists have tried many different ways of predicting earthquakes, but none have ever been successful. So again, they have tried, but nothing has ever been successful to predict. So again, man has tried, but has failed at predicting earthquakes, just like man has tried and failed at predicting tornadoes. It just doesn't. It doesn't happen when it comes to that. So, on any particular fault, scientists know there will be another earthquake sometime in the future, but they have no way of telling when it will happen. So, if you look at a fault, scientists know that there will be another earthquake sometime in the future, but the predictability is not there. It's just a wild guess. It's just throwing out, guessing. It's throwing out numbers. It's just throwing out whatever and guessing where and when it might happen. So again, there is no scientific data. There is no scientific proof to ever predict an earthquake. It's just not there. And if anybody tells you that there is, they are either lying to you or they're messing with you, because there is nothing that is ever in the weather community, to predict that an earthquake will happen and where it's going to happen at. So do not believe anybody or somebody if they tell you they can predict when the next earthquake is going to be. It's not possible. So again, don't believe that person if they tell you that. Because remember, I'm here to tell you, I am here to tell you reliable, trustworthy information, the truth, it's accurate, that you guys can all count on 100%. So when it comes to that, and again, I will tell you transparently, I will tell you very raw, I will tell you very openly, and I will tell you again very transparently about information. So again, be careful where you get information from when it comes to that. So is there is there such a thing as earthquake weather? So this is a great question, because sometimes and we'll get into that just a little bit. Can some animals or people tell when an earthquake is about to hit? It's kind of like when people say, "Well, hey, my arthritis is acting up, and I feel like it's going to storm or it's going to rain." It's kind of that same kind of pathways, the same kind of thinking when it comes to that. So there are two questions that do not. These are two questions that do not yet have definitive answers or definite answers. If weather does affect earthquake occurrence, or if some animals or people can tell when an earthquake is coming, we do not yet understand how it works. So it's possible, maybe, but in science, it's just not in meteorology, climatology, geology. It's not understood why, if people or animals could tell or anticipate if an earthquake is coming. From those sides of things, it's just not understood uh, in that scientific community when it comes to that. So, again, is it possible? Maybe, but it's just not understood because there's no definitive answers. And again, when you look at the USGS here, they do not outright just say no. They do not outright say, "Oh, that's crazy talk" or whatever. No, they just say, "Hey, there's no definitive answers," and it is possible that maybe um, the animals and people might be able to, kind of somewhat anticipate that, due to certain the way they feel, certain parts of the body, things of that nature. So again, you just never know when it comes to that. So um, like if it's about to happen like right away or something. So when it comes to that. So anyways, that's basically again kind of like right before it storms, kind of like when it starts to get cold, kind of like if the air temperature is changing, things of that nature, and and things like that. So when it comes to that, so again, that's what is how they talk about that on the USGS. So if we get back into the epicenter a little bit, so again, this is talking about the three seismographs that are used and plotted out here. So again, this is where they meet at. So where these three seismographs meet, these are the radiuses of the seismographs. Here's the radiuses. Where they all meet at, they meet right here. This is where they meet. So that is where the epicenter is at. So this gives you a visual. So where those three meet, the very point they meet at is the epicenter of that earthquake. So again, just a great picture to kind of give you an illustration of what's going on there. So when it comes to that, so next we're going to jump into a little bit more into magnitude. We're going to jump into a little bit more of that and get a little bit more in depth on that. So hopefully you guys are still enjoying yourselves. Hopefully you guys are still having a great Monday night. You're having a great weather seminar here, great weather session. Thank you to everybody who is on Twitch watching. Thank you to everybody who is on YouTube watching. Thank you to everybody who is on Facebook watching. Thank you to everybody who is on Kick watching. Thank you guys so much. All of your support is just great. It's very awesome. Very thankful, very blessed for all of your support. Again, you guys are awesome when it comes to that. And trusting in me again to be a reliable source and to be a trustworthy source that you guys come to. I highly, highly appreciate that when it comes to that. So, and again, as I talked about, if you guys were here for my last weather session or before I got into everything, as I talked about in my last live stream, I do plan on going live during severe weather events and things happening. Uh, tomorrow, um, there is an enhanced risk that's already out for tomorrow up in northern New England. So if we're looking at like Maine and New Hampshire and Vermont and very, very northern parts of New York and things of that nature. So tomorrow, depending on how it looks, might be my first time jumping on and going live and doing live severe weather reporting. So if you see me on tomorrow, that would be why. So please join me and please stick around for that. So when it comes to that, uh, Lisa says, "Oh, is he really?" She says, "John." So she's talking about. For those who don't know, she's talking about Brother John McKinney, Pastor John McKinney. John is traveling right now to chase in New England. Wow. That's awesome. That's awesome, Lisa. That is very cool. I'm very, very happy that he is. That is so cool. So yes. So good. So hopefully, so definitely looking forward to seeing Brother John on tomorrow. Remember, is now using Weatherfront. He is no longer with Radar Omega. Um, he is now with Weatherfront. So that is awesome that he is traveling out there. That because that is a long way, especially away from Nebraska. That's a long way. That's a long way out there. And we're talking like way up in pretty much tree land and forest land. So it's going to be a lot different. It would kind of somewhat be comparable to chasing in Dixie Alley. So comparable to chasing in like Alabama and Mississippi and things of that nature. But again, up in that region, it's very, very hilly. Up in northern New England, lots of forest, lots of trees. So yes, you definitely have to be more on guard. Well, you're always on guard no matter what, right? But definitely, you definitely have to um, uh, be looking and be yeah. Just obviously, just make sure your guard is never let down because, uh, especially looking through the trees and everything like that, because it's hard enough to chase when it's flat land, but it's even harder to chase when you're going through hills and trees and forests and everything else. So, but again, I hope he has a great chase out there. Hopefully, he has a safe drive out there. Thank you for letting me know, Lisa. I really appreciate that. That's so awesome that he's doing that. Uh, I'll probably text him here then later and, tell him praying for him and looking forward to seeing him on then tomorrow. So appreciate that, Lisa. Thank you so much for that. So when it comes to that, so again, so this is basically part one of the topic. We got into the science, what an earthquake is, how they're measured, where they happen at, how they happen, things of that nature. So when it comes into that, so we will jump in to part two here shortly. So when it comes to that, but again, just want to take a minute here to say thank you to everybody who is watching on YouTube. Thank you to everybody who's watching on Kick. Thank you to everybody who's watching on Facebook. Thank you to everybody who's watching on Twitch. So again, I am multi-streaming and I will be multi-streaming. I am trying to penetrate and gain traction on the other platforms as well when it comes to that. So if you are new here, welcome to John Boy Severe Weather Lab and Education. Welcome to my channel. My channel again is is branded and is dedicated to severe weather and educating individuals on severe weather and all the topics that surround severe weather and just weather in general when it comes to that. So, again, welcome to John Boy Severe Weather Lab and Education. Glad you guys are all here. So let's jump in to the next part of the session here. So, again, we just covered part one. So, we talked about a little bit um, about the magnitude, right? We talked about the earthquake magnitude. We talked a little bit about the energy releasing because remember when the earth slips, it creates all. Remember, the ridges are stuck together. The tectonic plates ridges are stuck together. The plates are still moving around them, and then once they unstick, they create all of that energy. They create all of that force, and then that energy dispels out and disperses out in a seismic wave, which is the same illustration if you throw a rock in a pond, throw a rock in a lake, whatever it is, and it makes that ripple effect. It's the same concept when it comes to that. So, earthquake magnitude, energy release, and shaking intensity are all related measurements of an earthquake that are often confused. Yes, they do get confused with one another. So I'm here to hopefully, if you are confused, I'm here to unconfuse you and make you not confused. Uh, their dependencies and relationships can be complicated, and even one of these concepts alone can be confusing. Yes, I've been confused myself before I learned more about this and everything else. So when I was, younger and everything else, yes, it was confusing when it came to this stuff. So, but once you learn it and once you deep dive into it a little bit more, the confusion starts to go away and it gets easier to understand. But again, magnitude. So we will jump into magnitude. And we talked about that a little bit, so I'm not going to beat that over the head again. But again, the time, location, and magnitude of an earthquake can be determined from the data recorded by seismometer, which we talked about, a seismograph, seismogram. Seismometers record the vibration. Thank you, Debbie. Debbie, for being back. Appreciate that. Thank you so much, Debbie. You are awesome. Thank you. Seismometers record the vibrations from earthquakes that travel through the earth. So again, we talked quite a bit about this already. But if you just joined, I will touch base on it. Each seismometer records the shaking of the ground directly beneath it. Sensitive instruments, which greatly magnifies these ground motions, can detect strong earthquakes from sources anywhere in the world. Modern systems precisely amplify and record ground motion, and we're talking precisely, typically at periods of between 1/10 and 100 seconds. So 0.1 and 100 seconds as a function of time. So very, very precisely. And remember, magnitude is the size of the earthquake. An earthquake has a single magnitude, and the magnitude is what we hear. It's put out in the media: 7.0, 6.2, 6.5. That is magnitude. That's what's used when it comes to that. So the shaking that it causes has many values that vary from place to place based on distance, type of surface material, and other factors. When it comes to that. And it looks like I see a new person in chat. Looks like we got Julie in here. Thank you, Julie, for joining. Thank you, Julie, for being here. Great to see you. Great supporter, great encourager. Thank you very much, Julie. Appreciate that so much for being here. So thank you. So again, an earthquake has a single magnitude. The shaking that it causes has many values that vary from place to place based on distance, type of surface material, and other factors. See the intensity section below for more details on shaking intensity measurements. So we will get into what's called intensity as well. So there is intensity and there's magnitude, and there's energy. So again, uh, not to be confused, hopefully to help with any confusion there. So, types of magnitudes. Magnitude is expressed in whole numbers and decimal fractions, like I talked about 7.0, 7.2, 6.1, and so on and so forth. So, when it comes to that, um, so, for example, a magnitude 5.3 is considered a moderate earthquake, and we will talk about the way that they, on the magnitude scale or on the Richter scale, which is now actually, they actually use a different scale. It's called the MW scale, which they say is more precise reading of the magnitude, but Richter scale still sticks around because it's been around forever when it comes to the magnitude scale of earthquakes. But nonetheless, when so a 5.3 is a moderate earthquake and a 6.3 is a strong earthquake. So, because of the logarithmic basis of the scale, each whole number increase in magnitude. So each time it increases in a whole number. It represents a tenfold increase measured in amplitude as measured in a seismograph. So it's a tenfold increase in amplitude. That's what's going on there. So again, to break that down a little bit, a 5.3 is moderate, but a 6.3 is considered strong. So when it comes to that, and again, what is happening there? Because of the logarithmic basis of the scale, each whole number increase in magnitude represents a tenfold. So remember, it's tenfold. It's tenfold increase in developed all magnitude scales based on measurements of the recorded waveform amplitudes were thought to be equivalent, but they're not. But for very large earthquakes, some magnitude overestimate true earthquake size and some underestimate the size. Thus, we now use measurements that describe the physical effects of an earthquake rather than the measurements based only on the amplitude of a waveform recording. More on that later. So again, they get into that a little bit more scientifically. So again, it's not the most fun part. It's not the most glamorous part, but it is a huge part of how to understand what is going on there when it comes to telling us how strong, how much energy is being released, how strong that earthquake is. So when it comes to that, so again, the Richter scale. This is again, you've heard me talk about it. This is what is used all the time in the media. This is what has just been around in use uh, ever since earthquake reporting basically became a thing with magnitude and things of that nature. So the Richter scale is what most people have heard about. Yes, that is true. And raise your hand and let me know if you have heard what the Richter scale is or if you've heard of the Richter scale before. So please let me know in the chat if you've heard of the Richter scale. So please let me know. So the Richter scale is what most people have heard about, but in practice, it is not commonly used anymore. So again, it is what everybody has heard about, what everybody has basically seen, but it is not regularly used anymore nowadays in present time reporting when it comes to that. So, uh, when it comes to that, so it looks like so the Richter scale is what most people again have heard about, but in practice, it is not commonly used anymore, except for small earthquakes recorded locally, for which ML in short period surface waves magnitudes are the only magnitudes that can be measured. For all other earthquakes, the moment magnitude MW scale. So this is again what is this is basically what they use. So they use again again, this is what they use. They use the they are using the MW scale. So when it comes to that, but yes, when it comes to that, so let me know if you guys are still uh having a great time. Still, I know this isn't the most glamorous part of it, but again, hang with me here through this, and then we'll get to some more exciting, fun parts when it comes to that. So, let me know if you can hear me and see me okay, and that everything is coming through good for you guys. So, appreciate that. So, please, again, let me know. Um, Again, this isn't the most fun part of it, but stick around and um, we'll get to some more funner some more cool facts about earthquakes. So just hang in there. I know how it can be when things get a little bit tedious. Trust me, I completely know when it comes to that. So definitely appreciate all of that. So again, what is being used nowadays is mostly being used is called the MW scale, or the moment magnitude scale. Is a more accurate measure of the earthquake size. So that is what is being used mainly nowadays over the Richter scale. So again, that's what's being used when it comes to that. So although similar seismographs had existed since the 1890s, it was only in 1935 that Charles Richter, a seismograph or a seismologist at the California Institute of Technology. So hey, this guy's from California. This is where this guy's at. Introduced a concept of earthquake magnitude. His original definition held only for California earthquakes occurring within 600 kilometers of a particular type of seismograph, the Woods-Anderson torsion instrument. His basic idea was quite simple. By knowing the distance from a seismograph to an earthquake and observing the maximum single amplitude recorded on the seismograph, an empirical quantitative ranking of the earthquake's inherent size or strength could be made. So again, this guy is from California Institute of Technology, and this is happening in 1935. So pretty early on here when it comes to stuff. So when it comes to that, so most California earthquakes occur within uh, most California earthquakes occur within the top 16 kilometers of the crust. To a first approximation, corrections for variations in earthquakes' focal depth were therefore unnecessary. So again, the Richter magnitude of an earthquake is determined from the logarithm of the amplitude of waves recorded by seismographs. Adjustments are included for the variation in the distance between the various seismographs and the epicenter of earthquakes. Okay, so it's just talking about, it's just getting into a little bit, just a little bit deeper about the Richter scale, getting a little bit deeper about the 16 kilometers happening off the crust in California. It's in talking a little bit about adjustments that had to be made along the way. So, just a high level overview, not to bore you too much with that. So now we get into what are MW, MOs, things of that nature. And this gets into some pretty logarithmic and arithmetic calculations here. So yes, there is math that is used in calculating earthquakes. So it's logarithmic when it comes to that. It's not fun per se, but there is a lot of arithmetic when it comes to earthquake. A lot of earthquakes. So MW, as we talked about, it's based on physical properties of the earthquake derived from an analysis. When it comes to that, so first the seismic moment is computed, and then it is converted to magnitude designed to be roughly equal to the Richter scale in magnitude ways where they overlap. Where rigidity is the strength of the rock along the fault area is the area of the fault that slipped. and slip is a distance the fault moves. So remember, this is again a little bit more scientific. It's getting to a little bit more arithmetic, but again, it's going to help you understand what is going on here um, with earthquakes here. So, where rigidity is the strength of the rock along the fault. So, how strong is the rock that the fault is penetrating against? So that is stuck into. The area is the area that the fault slipped. So how far did the fault slip? Like that's the area of it that slipped. And the slip is the distance that the fault moved. So how far did the fault move? Did it move a couple inches? Did it move a couple feet? Whatever it is. So we have rigidity, we have area, and we have slip when it comes to that. So thus, stronger rock material or a larger area or more movement in an earthquake will all contribute to produce a larger magnitude. So think about this. If you have stronger rock material, if there is a larger area of movement, or if there is more movement in the earthquake, any one of those can contribute to producing a larger earthquake, a larger magnitude. So again, stronger rock material, so it's more rigid, brushing up against each other, a larger area, or more movement in the earthquake. So when it comes to that, so just remember that those three things. And then just gonna talked about the ranges, distant ranges, equations, and a brief description of each. So yes, so we talked about that. So that's basically magnitude, how the magnitude is calculated, and how the magnitude, again, is shown on seismographs and things of that nature. So another way to measure the earthquake, and this is the second part, is the energy released. How much energy is released in that earthquake. So another way to measure the size of an earthquake, the size of an earthquake is to compute how much energy it released. The amount of energy radiated by a earthquake is a measure of the potential for damage to man-made structures. So again, the amount of energy radiated by an earthquake is a measure of the potential for damage to man-made structures. So that's how they do it. An earthquake releases energies at many frequencies, and in order to compute an accurate value, you have to include all frequencies of shaking for the entire event. So there is a lot of computation that's going on, a lot of that's happening here, a lot of calculation that's going on here to understand the amount of energy that was released. So while each whole number increase in magnitude represents a tenfold increase in the measured amplitude, it represents a 32. Remember this, 32 times more energy released. So if you go from a 2.0 to a 3.0, that is 32 times more energy released. So yes, it's tenfold. So it's tenfold on the increase from the magnitude, but it's 32 times more energy that is released. That is huge. That is just going from one whole number to the next on the magnitude. So again, each whole number represents, or just going up, represents 32 times more energy release. So the energy can be converted into yet another magnitude type called energy magnitude. However, since the energy magnitude and moment magnitude measure two different properties of the earthquake, their values are not the same. The energy release can also be roughly estimated by converting the magnitude to energy using the equation. And again, this is where arithmetic comes in. This is where This is where logarithm comes in. This is where all this comes into play at. And again, they have the logarithmic down or written. So log E equals 5.24 plus 1.44 MW, where MW is the moment magnitude. So if you know that equation, you can understand, you can convert the moment magnitude to energy using that equation. So once you know the equation, you can solve that problem. And um, again, it's just knowing the equation that is used. So that is energy release. So remember that anytime that magnitude is it's remember it's a tenfold in magnitude, but remember it goes up 32 times more energy released when it goes up one full point or one whole number. So that's a lot of energy that is being released. The third part, intensity. Again, intensity is whereas the magnitude of an earthquake is one value that describes the size. There are many intensity values for each earthquake that are distributed across the geographic area around the earthquake epicenter. The intensity is a measure of shaking at each location, and this varies from place to place, depending mostly on the distance from the fault rupture area. However, there are many more aspects of the earthquake and the ground it shakes that affect the intensity at each location, such as what direction the earthquake ruptured and what type of surface is directly beneath you. Intensities are expressed in Roman numerals. For example, 6, 10, 4, 3, things of that nature. So, when it comes to that, so traditionally, the intensity is a subjective measure derived from human observations and reports of felt shakings and damage. The data used to be gathered from postal questionnaires. The data used to be gathered from postal questionnaires, but with the advent of the internet, it's now collected using a web-based form. However, instrumental data at each station location can be used to calculate estimated intensity. The intensity scale. The intensity scale that we use in the United States is called the modified Mercalli intensity scale. But other countries use other scales. So again, we use what we use, and we use what is known as the MMIS, or the modified Mercalli intensity scale. That is what we use because that's what we have. So when it comes to that, and again, we get into a little bit of examples, intensity shaking, things of that nature. So don't want to bore you too much with that stuff. But however, why this section is very important to the lesson, why this section is very important to the teaching, because if we have magnitude, we need to understand energy. With energy, we need to understand intensity. So we need to understand what those three are going on, what those three are doing for the earthquake. So and how those all are in part relation to the earthquake there. So we need to know the magnitude, the energy, and the intensity that's going on. So these are just great pictures that are kind of going to show you some, some shaking, some intensity, things that nature. And we'll look a little bit more into the intensity as well with a great graph on the magnitude scale, what that looks like. So when it comes to that, and we'll just get a little bit more into that. Not gonna stick too much on that when it comes to that. So then I'm not gonna talk too much about this either. I want to get into much into that. So when it comes to that, but so this section again, not the most awesome section or whatever it is, but still a very key part in the teaching and understanding what's going on between magnitude, energy, and intensity. So again, that's just great to know when it comes to that. So that is part 2 of tonight's session. So we will move on to part 3 when it comes to that. So Libby says, that is great that you help your mom, Lonnie. Yes, it is. Very awesome of you, Lonnie, for helping your mother. That is very cool. Very awesome of you. Appreciate that very much. So, when it comes to that. So, but yes, very thankful for all of you. Very thankful for everybody on Twitch. Very thankful for everybody on Facebook. Very thankful to everybody who's watching on YouTube, and very thankful to everybody who is watching on Kick. You guys are all awesome. If you just joined in, or if you are new here, please like, please subscribe, please share. Please let me know um, if you enjoy my content. And if you do, I hope you stick around. And if not, I do appreciate you being here and checking it out, because my content will not be for everybody. But nonetheless, thank you for being here, and welcome to John Boy Severe Weather Lab and Education, where you will learn all about severe weather, and where you will feel like family, and where you will get trusted, accurate, reliable information when it comes to that. So, again, thank you all for being here. And if you are new, please like, please subscribe. And I hope that you do enjoy my content. But again, if not, I still appreciate you being here and appreciate you taking the time to check me out. So, and I appreciate everybody who is in here right now. I know all of you could be spending your time listening to somebody else, or doing something else, or watching something on TV, or whatever it may be, playing with your kids, playing with grandkids, whatever it may be. I appreciate you all taking the time and listening to a guy like me talk to you and teach you and educate you about earthquakes. So, thank you very much for spending your valuable time with me and putting your time, valuable time, trusted in me. So, thank you for that. So, we talked about part 1, we talked about part 2 when it comes to that. So I appreciate that very much. So again, so now we're going to talk about a little bit about. I want to talk about just kind of giving an overview of what the Richter scale, kind of when they utilize it, what it broke down to being. So, and what I mean that is kind of like where the magnitudes are rated at and what they get rated on: strong, moderate, great, things of that nature. So, if it's a less than a 2.0 magnitude, it's just considered a micro. That's what it's considered. If it's 2.0 to 2.9, it's considered minor. 3.0 to 3.9 is considered light. 4.0 to 4.9 is considered moderate. 5.0 to 5.9 is strong. 6.0 to 6.9 is considered major. Anything that is 7.0 or greater is considered great. These are the worst ones. Anything 7 or 7.0 or greater are the worst ones. And as it says, these earthquakes cause serious damage. So anytime you hear 7.0 or greater, these are serious, very serious earthquakes. They happen around 10 to 20 times per year globally. There is usually only one earthquake per year with a magnitude between 8 and 10, although 10 is misleading because no earthquake of 10 or higher has ever been recorded. And we will get into what is the highest magnitude ever recorded. So, again, this is the scale. Goes from micro, minor, light, moderate, strong, major, and great. So anything at 7.0 is a great, considered completely severe, serious earthquake when it comes to that. So, again, wanted to point that out to you when it comes to that, kind of give you a visual and show you that scale when it comes to that and what it looks like there. So, so there's some very great stuff from that. That is the part that is on the Richter scale there. So again, there has never been an earthquake in recorded history that's ever been recorded at 10 or above. So very, very thankful for all that. Very thankful for all of you for being here. And again, just there has never been a 10 that has ever been recorded in recorded history. So, but yes, Lonnie says, I'm happy to be here with my family and friends tonight. Thank you. Thank you, Lonnie, for being here. Thank you for being an encourager. Thank you for being a supporter. Appreciate that. So thank you for being a part of John Boy Severe Weather Lab and Education. Thank you so much for that. Definitely appreciate that. So again, don't want to beat that over the head, but that again is showing you how on that scale. So if you were to hear, oh, there's a 3.1 today in California, you could go, oh, okay, so that's considered a light earthquake. So at least considered light on the Richter scale. Might not be considered light to somebody who felt it, but that's just considered light on the Richter scale. So again, point that out. So want to jump over to what we talked about here before. We talked about the tectonic plates, and there's 3 ways that really these boundaries move when it comes to that. So it's going to talk about, so there is called convergent movement or a convergent boundary. There's divergent, and there's transform or transformation boundaries. So a convergent boundary, so this is a way that plates move towards each other, often resulting in subduction zones or continental collision. These boundaries produce some of the largest and deepest earthquakes. So they're converging, they're coming together. So these are converging. Divergent plates move apart from each other, creating new crust at mid-ocean ridges. Earthquakes are typically shallow and less powerful, so now they're moving apart. So they're creating friction and force as they move apart. So that is divergent. Convergent is coming together. They move towards each other, often resulting in subduction. So they're going underneath each other, and the zones and subduction, creating subduction zones or continental collision. So when it comes to that, Omni makes a good point, and that is actually on one of the things I'm going to talk about here. But yes, Omni is correct that the largest or the strongest, I should say, it's not the largest, but the strongest on the magnitude scale ever recorded is a 9.5 in Chile. I believe around 1960, but we will get into that. And that's going to be part of the 20 largest or 20 strongest earthquakes ever recorded. But thank you, Omni, for pointing that out. Thank you very much. So again, we got convergent, we got divergent, so coming together, we got going apart. Now we have transform boundaries, plates that slide past each other. So now they're sliding past each other. So now they're going like this. Sliding past, sliding past, sliding past. That's what's happening when it comes to that. So divergent, right? Divergent, they're going apart. Convergent, they're coming together and then going over on top of each other. One's going under, one's going on top. Convergent, divergent, they're going away. So transform, they're sliding past. Bam, bam. I don't know if y'all can see that. It's going this way, that way, sliding past. When it comes to that, so when that happens, so plates slide past each other horizontally, generating shear stress. And if we know about shear, we know about wind shear, right? We know about what shear is. So when it comes to tornadoes and things of that nature, but I digress with that and get back onto this. These boundaries are the site of frequent, shallow, and potentially strong earthquakes, e.g., the San Andreas Fault. So the San Andreas Fault, that is what runs through California. That is what runs through most parts of California, through a lot of California. So California sits on a transform boundary or a transformation boundary when it comes to that. So generally, those plates are sliding past each other. That's what's happening there on the San Andreas Fault. They are sliding past each other and creating friction when it comes to that. So that leads us in types of fault. So there are basically three types that the plates can move, right? But they can move. So it's convergent, divergent, or it's transforming. So it's sliding past. So that's basically the three ways that the Earth is moving in order to create that earthquake when it comes to that. So, types of faults. There are normal faults occur when the crust is being extended. The hanging wall moves downward relatively to the foot wall. Reversed thrust faults from where the crust is being compressed, so pushed together. The hanging wall moves upward relatively to the foot wall. Strike slip faults characterized by horizontal movement where blocks of crust slide past one another. That's what San Andreas Fault is. It's a strike slip fault when it comes to that. So driving forces of plate movement. So there's mantle convection. Heat from Earth's interior drives slow-moving convection currents in the mantle, pushing plates along. So mantle convection, just like there is convection, here in the atmosphere, the convection that creates storms and rain and everything else, there is mantle convection going on underneath the Earth's surface. There is, so how cool is that? There is a ridge push. Elevated mid-ocean ridges create gravitational force that pushes plates away from spreading centers. Slab pull, dense subducting plates sink into the mantle and pull the rest of the plate with them. So again, that is what's happening with slab pull. So causes include tectonic plates movement, faulting, volcanic activity, which we know volcanic activity can induce volcanic earthquakes. Human activities can actually produce earthquakes, and that is mining, reservoir-induced seismicity from dams, and fracking can cause earthquakes. Excuse me. Landslides and collapse events in caves or mines can cause usually small earthquakes. So yes, human activities can cause earthquakes. And when it comes to that, so talked about that. We talked about that and swarms and other type when it comes to that. So wanted to talk a lot about that. So when it just comes to that and show you the three basic types when it comes to that point. So again, we got convergent, divergent, and transform. When it comes to that, those are the three main ways that the Earth is moving in order to create that earthquake when it comes to that. So that is part 3 of tonight's lesson. So now we start to get more into the fun part of the lesson and more less of the scientific side of things and what's going on. So this will be a little bit more fun or funner than what we've been talking about. But again, I appreciate you guys sticking through the tough parts of the scientific side of things, unless you enjoy the scientific side of things and the science of it. So if you're like me, I enjoy the science of it. I enjoy that. So I hope you guys enjoyed some of the science side of it for earthquakes when it comes to that. So that was part 3. So we will move on to part 4, which we will get into some cool earthquake facts. So let's get into some cool facts. Who's ready for some cool facts about earthquakes? Because I am ready for some cool facts, and I hope all of you are ready for some cool facts as well. And again, thank you all for being here. Thank you for being part of John Boy's Severe Weather Lab and Education. Thank you for tuning in. Thank you for being part of this community. Thank you again for trusting me as to be a reliable source for you when it comes to weather. So, thank you so much. Let's jump in to some cool facts. So, here we go. The largest recorded earthquake in the United States was a magnitude 9.2. Almost a record. The record is 9.5. This is a 9.2. This happened in Prince William Sound, Alaska on Good Friday, March 28th, 1964. So this is referred to as the Good Friday earthquake. So if you ever hear of hear somebody talking about the Good Friday earthquake, this is exactly what they're talking about. And if you see from this picture here, over here, you can see the huge hole that it carved out in the road from shaking. So this is not supposed to be here. This is a big hole. This is the pavement, each side of the highway splitting from each other. So again, that's not supposed to be there when it comes to that. So again, that is the largest one in the United States, or I should say, the strongest one in the United States. Sometimes you'll hear largest, really it's strongest, 9.2 on the magnitude. So that happened on Good Friday in Alaska. Talk about the second point. The second point is what we discussed just a few minutes ago that Omni pointed out. The largest recorded earthquake in the whole entire world was a 9.5 in Chile on May 22nd, 1960. So a 9.5. So again, out of this, mind-blowing, 9.5. That is ridiculous. So again, 9.5 is the largest ever in the world. The earliest reported earthquake in California was felt in 1769. So we're going back. What are we going back? 200. Or wait, what is this? This is 2026. Yeah, we're going back 200 plus some years. So when it comes to that, over 250 years. So 1769. Actually, I think that's like 257 in my head or something. I don't know what it is, something like that. By the exploring expedition of Gaspar de Portolo, while the group was camping about 48 kilometers or 30 miles southeast of Los Angeles. So, the earliest reported earthquake in California, 1769. Before electronics allowed recordings of large earthquakes, scientists built large spring pendulum seismometers in an attempt to record the long period motion produced by such quakes. The largest one weighed about 15 tons, so about 30,000 pounds, or about 30,000 pounds. So, when it comes to that, there is a medium-sized one 3 stories high in Mexico City, and it's still in operation today. It is still in operation today. There's a medium-sized one 3 stories high, so it's 30 feet high in Mexico City, and it's still in operation. Pretty wild for today's standard. The fastest wave, and therefore the first to arrive at a given location, is called a P wave, which we already talked about, so I'm not going to get into that. Not going to get into that. This is a cool thing, though. I'm going to talk about moonquakes. Moonquakes. Moonquakes, or called earthquakes on the moon, do occur, but they happen less frequently and have smaller magnitudes than earthquakes on the Earth. It appears they are related to the tidal stresses associated with the varying distance between the Earth and Moon. So, yes, the moon does have quakes on it, it does have tremors. How cool is that? How many of you knew that the moon experiences earthquakes? That is pretty cool. Oh, awesome. And it looks like got a new subscriber here. Thank you, Ma, for subscribing. Thank you so much. Appreciate you subscribing. Appreciate you being here. But again, how many of you knew that the moon has earthquakes? Let me know. They also occur at great depth, about halfway between the surface and the center of the moon. So, again, just pretty cool stuff. So, when it comes to that, although both are sea waves, a tsunami and a tidal wave are two different, unrelated phenomena. A tidal wave is a shallow water wave caused by the gravitational interaction between the sun, moon, and earth. A tsunami is a sea wave caused by an underwater earthquake or landslide, usually triggered by an earthquake displacing the ocean water. So, again, I think we all know and have seen some pretty devastating tsunami effects of what have happened when some big earthquakes have happened. We can think about, I believe it was Indonesia in Christmas Day, the day after Christmas in 2004. Then the Japan one in, I believe, 2011. Those tsunamis were absolutely devastating, horrific, caused so much damage. Unfortunately, loss of life, loss of structures, loss of valuables, loss of livestock, loss of a lot of things. So, again, tsunamis, we know, unfortunately, do come from stronger earthquakes. So, we talked about the hypocenter before. We talked about the epicenter. Not going to talk to you. Not going to beat that again. Now the Ring of Fire. You guys have probably heard the Ring of Fire, especially if you live in the Northwest. So like Sonia, I think Julie's out there in the Northwest or in the West somewhere. So if you live out there in the West or Northwest, you most likely have heard the Ring of Fire when it comes to that. So the Ring of Fire, it is what you see here on the map. It goes like this. It's like this. This is the Ring of Fire. It's also a Johnny Cash song. But yes, this is the Ring of Fire. So this is the Ring of Fire. And we'll learn a little bit more about the Ring of Fire. Welcome in, Eduardo. Thank you, Eduardo, for being here. Appreciate that. Thank you for subscribing, Eduardo. Thank you so much. Appreciate you for subscribing. Thank you. Definitely appreciate that. So, when it comes to that, so yes. So Sonia says totally familiar about the Ring of Fire. Definitely, because Sonia is in the Northwest. Sonia is in the state of Washington. So definitely, again, if you live out that way in that direction, you most likely know what the Ring of Fire is, because you are a part of that. So when it comes to that, but yes, when it comes to that. So the Ring of Fire, also called the Circum-Pacific Belt, but nobody calls it that. Everybody calls it the Ring of Fire. Nobody calls it the Circum-Pacific Belt. Only in some scientific communities, but everybody else calls it the Ring of Fire. Is the zone of earthquakes surrounding the Pacific Ocean, and again, the Pacific Ocean. And this is wild stat. So this is a very, very wild stat that you're about to see when it comes to that. So About 90%. So about nine out of every 10 earthquakes that happen. So 9 out of every 10, 90% of earthquakes all happen basically in the Ring of Fire region. That is wild. That's why it's called the Ring of Fire, because it's getting 90% of all of the Earth's earthquakes. All the 10% are spread outside of that Ring of Fire, and they happen wherever and whenever. But basically, 9 out of 10 earthquakes happen in the Ring of Fire region. So again, that is very wild. That's why it's called the Ring of Fire. So, the next most seismic region, 5 to 6% of earthquakes, is the Alpine Belt, extends from the Mediterranean region eastward through Turkey, Iran, and northern India. So that region gets about 5 to 6%. And then the Ring of Fire gets 90% and everything else. So again, the Ring of Fire, again, is super, super active all the time. 90%, 9 out of 10 earthquakes happen there in that zone. So, estimations. It is estimated that 500, it is estimated that there are 500,000 detectable earthquakes in the world each year. So with all the instruments that we have, all the instruments that we utilize all across the world, there are about 500,000 detectable earthquakes. So that is a lot of earthquakes throughout the world every year. And only about 100 of those are felt. So about 1 in 5 are felt, like we feel them. And only about 100 of them cause damage. So again, we're going from 500,000 detected. Now we're going down to 100,000 that can be felt. So 1 in 5. And now we're going from that. We're going from going from 100,000 down to 100 of those are what cause damage. So again, we're going from a large number down to a very, very tiny, small, minute number compared to where we started at 500,000. So that is that's a very good thing that we go from that only 100 or so are what cause damage instead of the 500,000 or 100,000 or things of that nature. So it's a very good thing. And Libby says, interesting that only 1 in 5 are felt. Yep, exactly. So that's what they say, and that's what the data points to. So again, 500,000 detectable, 100,000 can be felt, and only 100 of them cause damage, which we know 100 of them is too many. But again, at least it's only 100 out of 500,000, and it's not 1,000 or 100,000 out of 500,000. So thankfully, when you look at it from the grand scheme of things, at how many there are detected each year, thankfully only a small number it caused damage. So that is a great thing for that. So it is thought the more damage was done by the resulting fire after the 1906 San Francisco earthquake than by the earthquake itself. So just point out some information there. A seiche. I don't know. Maybe you guys have heard of this on the West Coast, called a seiche. It's what happens when in swimming pools in California during and after an earthquake. It is an internal wave oscillating in a body of water. Or in other words, it is the slashing of the water in your swimming pool or any body of water caused by the ground shaking in an earthquake. It may continue for a few moments or hours, long after the generating force is gone. A seiche can also be caused by wind or tides. So that might be known, maybe more known out there on the West Coast. I am not familiar with that here in the Midwest. But yeah, so maybe some of you knew that out there. Whether you just knew that outright or maybe out there on the West Coast again. When it comes to that, so interesting stat here. Each year, the Southern California area has about 10,000 earthquakes. 10,000. That's crazy. Most of them are so small that they are never felt. Only several hundred are greater magnitude than 3.0, and only about 15 to 20 are greater than magnitude 4.0. If there is a large earthquake, however, the aftershock sequence will produce many more earthquakes of all magnitudes for many months. So, again, so when it comes to that, so Libby says oscillating as in a circular motion or just sloshing back and forth. I think what they're meaning is when the ground shakes. I think it's yeah. From what they're saying, a seiche is it's an internal wave oscillating in a bottle of water, or but well we know oscillating means circling, or in other words, it is the slashing of the water in your swimming pool. So I think that they're meaning, yeah, I think they're meaning it's just slashing, like it's back and forth when they start shaking, and it's just the waves are, going back and forth. At least that's the way I'm interpreting it. Maybe that's not the way to interpret it, um, but that's the way that I look at it. So when it comes to that, so hopefully that makes somewhat sense about that. So but yeah, I think that's what they mean just by the slashing when it comes to that. So I'm not familiar with Sage. Like I said, I've never. I mean, I've read about it and I've studied it and everything, but I've not. I'm not like I've never witnessed one. I've never seen one. But as far as oscillating, I've never seen water like oscillate or spin because um, of a earthquake. Now that doesn't mean that it can't or that it doesn't. I don't know. I've never seen it though in my studies, in my weather studies. But I have seen it slosh back and forth. I have seen it, generate waves and generate speed and force and things of that nature and energy and slash back and forth. So, but as far as oscillating, I've never seen it like oscillate before. So, unless they mean oscillating in that sense of it going back and forth that way, and not actually like, like a fan oscillating. So maybe they mean it more like a fan. As a fan oscillates, it goes from one side to another. So maybe that's what they mean. Again, with the slashing with like that. So, but yeah, I think that's kind of my way of understanding that. So again, when it comes to that, so I want to talk to you about that, or about Manitou. We already beat Manitou over the head. Um, and the world's greatest, the world's greatest land mountain range is a Himalayas uh, Karakoram, or Himalaya Karakoram. It contains 96 of the world's 109 peaks over 24,000 feet. The longest range is the Andes of South America, which is 47,000 miles in length. Both were created by the movement of tectonic plates. So the movement of tectonic plates created those, or helped create those. Um, Obviously, it's God's creation, obviously, but uh, from this point of what you're understanding through this, but God is obviously the craftsman, the artist, things of that nature when it comes to that. So as far as we know, there is no such thing as earthquake weather. We kind of talked about that a little bit. Statistically, there is an equal distribution of earthquakes in cold weather, hot weather, rainy weather. If weather does affect earthquake occurrence, we do not yet understand how it works. So, whether you live in a warm climate, a cold climate, a cool climate, whatever it may be, there really is nothing that's going to give you better odds or better chances of not having an earthquake or have an earthquake. nothing that pertains to that. So from 1975 to 1995, there were only 4 states that did not have any earthquakes. So for a 20-year period, Florida, Iowa, there you go, Lisa. Iowa, Florida, Iowa, North Dakota, and Wisconsin for 20 years from 75 to 95 did not record an earthquake at all. So, when it comes to that, I'm going to go over some of that stuff. There's some other stuff. I wanted to point out here just real quick, too, for those on the San Andreas Fault. So, on the San Andreas Fault, the San Andreas Fault is not a single fault. It's not continuous. It's not a single continuous fault. But rather, it's actually a fault zone made up of many segments. Movement may occur along any of the many fault segments along the zone at any time. The San Andreas Fault System is more than 800 miles long. So again, it is not one long continuous fault. And in some spots is as much as 10 miles deep. So again, it is not a single continuous fault when it comes to that. So we talked about that. Florida and North Dakota had the smallest number of earthquakes recorded in the United States history. So if you happen to live in Florida or North Dakota, you basically are not going to see an earthquake when it comes to that. So, but if you happen to live in Alaska, Alaska is the United States' most earthquake-prone state. And this is a pretty wild fact. In one of the most seismically active regions in the world. When it comes to that, so Alaska experiences a magnitude 7 earthquake almost every year. It is very, very, very earthquake prone. So if you happen to live in Alaska, you live in the most earthquake prone state in the United States. So yes, very rumbly up there. So just a couple more here, and then talked a little bit about subduction before. It's a process of oceanic lithosphere colliding with and descending beneath the continental lithosphere. So talked a little bit about that. Won't get deep into that. And yes, the interior of Antarctica has ice quakes. So if you have any fascination with Antarctica like I do, very fascinated with the continent, the interior of Antarctica has ice quakes, which, although they are much smaller, are perhaps more frequent than earthquakes in Antarctica. The ice quakes are similar to earthquakes, but occur within the ice sheet itself instead of the land underneath the ice. Some of our polar observers have told us that they can hear the ice quakes and see them on the South Pole Seismograph Station, but they are much too small to be seen on enough stations to obtain a location. So yes, Antarctica is having ice quakes. So that is pretty wild in itself. So when it comes to that, so and then so look, so we talked about that. So that's some cool stuff there, but some pretty cool facts there. So that's more of the cool part of the session of the lesson today. So the last part, and I'll jump into it real quick here. These are the 20th largest or 20th strongest ever recorded earthquakes in history. So again, we have the 9.5 that happened in Chile. We had the 9.2 that happened in Alaska. 9.1. This is the one that happened on either Christmas Day or the day after Christmas in 2004. This was the ones that struck Sumatra islands, the Andaman Islands. I believe Indonesia was a part of that. I think there's some other locations out there as well. So that was huge. And then again, another 9.1 struck in 2011. This happened in Japan. So if you ever see video, and there is a ton of video out of Japan from 2011, if you ever watch the tsunami part of that, the tsunami coming in will absolutely blow your mind. It will absolutely blow your mind. I highly recommend, because seeing at least watching some of that, because what you will see is pure strength that water can do. The force, the energy behind that water. There is absolutely nothing. When that water came up, that water basically destroyed everything in its pathway, and you can watch it, and it's very, very wild to see happen. So to say it was devastating is beyond. It's I don't even. There was really even no words for that when you watch something like that. Very, very wild to watch when it comes to that. So 9.0 in Russia. So if you think about that, in recorded history, there have only been five. Count them: one, two, three, four, five. There have only been five There have only been five earthquakes in recorded history that have ever been 9.0 or greater. Five. That's it. So think of 9.0s as like the EF5 to tornadoes. Very, very rare. Tornadoes have the EF5s. It's earthquakes have the 9.0s. So 9.0s are like the EF5 of tornadoes. They just don't happen. They're very they when they do happen, it's very, very, very rare. So when it happens, so then we have 8.8 in Chile, 8.8 Ecuador, 8.7 in Alaska. So Alaska's again getting hit by a big one. 8.6 in Tibet, and 8.6 again off of Sumatra, which is again out there in Indonesia area. 8.6 Indonesia. 8.6 in Alaska again. 8.6 Alaska again. 8.5 in the Banda Sea. 8.5 Atacama, Chile. 8.5 in the Kuril Islands. 8.4 in Russia. 8.4 in Indonesia. 8.4 in Peru, and 8.4 in Japan. And again, we're talking about the Ring of Fire. For the majority of these are within the Ring of Fire when it comes to that. So, but again, so these are the 20 strongest earthquakes ever recorded. So again, the 9.0s and above are the EF5s of earthquakes. They're very, very, very rare, and they just do not happen hardly ever. So when we look at that 9.1 and that so they hit Japan and hit Indonesia in 2004, and then Japan 2011. That's why it was so devastating is because it was a 9.1. So that is the session for tonight. That is tonight's topic. Earthquakes. Again, an overview. Within about 2 hours or so, hopefully able to hopefully able to learn a little bit, maybe about stuff that you didn't know about, and stuff that kind of piqued your interest along the way with earthquakes. Again, hit you with a little bit of scientific side of things. I know that's not the most exciting stuff, but again, it is part of the lesson. So, but yeah, hit you with some cool facts. Hit you with some of the science when it comes to that. Hit you with all that. But again, this is stuff I have been studying for a long time. This is stuff that I love to study and then relearn and restudy, because you can never, ever stop learning when it comes to that. So, very thankful. But again, questions. If you have any questions, comments, concerns, feedback, Yes, please ask away, and please let me know. Oh, let me go. What did Libby just say? That was awesome. What I was reading there. What did Libby say? Libby says, I wonder what the earthquake at the crucifixion would have been rated. Broke rocks in half and open graves, and we don't hear of the damage from it. That is. What else did you say there? A supernatural earthquake. Yes. That. Um, that Libby. Probably there is probably would have been no instrumentation that could have recorded that. Probably that probably would have broke every instrumentation device. If there were instrumentation devices around at that time. But yes, that's probably was actually the most um, strongest, um, largest earthquake ever in the history of the history of the world. So definitely, definitely, very great point out there, Libby. That's very awesome. Very great point out. Very awesome. But yes, definitely would say that that would be the strongest ever recorded for sure. So uh, if they ever could have recorded it, so uh, but yes, definitely, Libby. That's an awesome uh, point out there. So W is for Libby. W is for Libby for that. So very awesome for Libby for that. So when it comes to that, so very cool. Libby says, and yet in his grace, it doesn't sound like there was much damage other than what was recorded. Yes, absolutely. Great point out there too as well. Yes, thank you. Thank you, Libby. Great point out there as well. Yes, W for Libby there, definitely. She nailed it there for sure, definitely. So thank you again to um, everybody who's watching on Twitch, everybody who is watching on YouTube, everybody who is watching on Facebook, and everybody who is watching on Kick. Thank you so much for being here. Thank you so much for um, thank you so much for being here. Thank you so much for helping. Thank you so much just for being a part of of John Boy Severe Weather Lab and Education. So thankful for that. So thankful um, for all of you. You guys are so awesome. Thank you guys so much. You guys again are very awesome. And again, if you have any questions, comments, concerns, let me know exactly what you have there. So definitely would love to answer any questions or anything like that. So um, yes, thank you, Lisa, for commenting on Kick. Thank you, Lisa, for commenting on Twitch as well. Thank you so much. Lisa's a huge supporter and encourager, a great sister in Christ, definitely. So definitely that, yes. Earthquakes are, yes, they're definitely, uh, just they're extremely powerful, right? I'll get back to that in a second. Lonnie says, good night. Debbie, Lisa, Libby, Sonia, and John Boy, sleep well tonight. My friends, see you later. Thank you, everyone. I appreciate all of you. Thank you, Lonnie, for being here. Thank you, Lonnie, very much. Appreciate you being here. Appreciate you joining in. Definitely appreciate that very much. So, um, very awesome, Lonnie. Thank you so much. So, definitely appreciate you being here, brother. I appreciate that, Lonnie. Good stuff. Good stuff, brother. So definitely appreciate that. So very awesome. Thankful to everybody who's in here. Thankful for everybody who is in here. So again, we have learned some great things about earthquakes tonight. We have learned about some science. We have learned about um, great things. We have learned about. Thank you, Anderson, or thank you, oh, Anderson de Andrade for subscribing. Thank you very, very much. Thank you for subscribing and for being here. Making my way close to 3,300 subscribers. So 3.3K, getting very close to 3.3K. It's very awesome. Very, very awesome to be almost at 3.3K. Such an amazing, amazing. I don't know what to even say, really. I mean, I don't know what to say. 3.3, is that's 3.3 more subscriber, 3.3 thousand subscribers than I thought I would get. So, uh, but yes, but thank you very much, Lonnie. Thank you for being here, brother. You guys are all awesome. So, well, yes, but very, very good. If you guys enjoyed the lesson, please let me know with a thumbs up or with yes or whatever it may be. But please let me know if you enjoyed today's lesson brought to you today's lesson in the John Boy Severe Weather Lab and Education. So definitely appreciate you all being here. Definitely appreciate you all being part of the rebrand. Appreciate all of that. So being part of this community, and yes. But like I mentioned before, I still will be making 7 in 7 videos. That's just not my brand. As I had started out, but my brand and my what I love, my passion is in live streaming, teaching severe weather and live weather, severe weather reporting. So that's that is my more of my expertise and more of my talent and skills when it comes to that. So, but yes, but I still do plan on making 7 in 7 videos because I still think that's a pretty cool niche, and I still think that's a pretty cool concept. And I do like making videos from time to time. But again, more of my talents and more of my skills, and more of that is in live streaming and teaching weather and educating people on weather and live weather reporting. So appreciate that from all of you. You guys are awesome. So, but yeah, so thankful to all of my supporters on Twitch. Thankful to all of my supporters on YouTube. Thankful to all of my supporters on Facebook, and thankful to all of my supporters on Kick. I will be looking in here sometime here, probably within the next month or so, about adding in possibly. I think I might be able to add in Twitter or X.com as it's called now. Might be able to add in another platform as well. Um, So very thankful for that. But looking to utilize as many platforms as possible. And as you can imagine, when you do go cross-platform, when you do multi-stream and go to different platforms, yes, it adds more work. It adds in more having to, update and things of that nature. But the work is worth it. So I definitely love putting in the work and doing that. I did see something here from Libby and from Debbie. Thank you, Debbie. Debbie says, "You're doing awesome there, John Boy." Thank you, Debbie. Libby says, "I love that you are using your gifts for his glory and all of our good." Thank you. That is my number one goal, is to use my gifts, my God-given talents and my gifts Obviously, for the glory of God, obviously, to glorify His name, number one, and to obviously help you guys as well, and to obviously help myself learn as well, because talking and teaching and educating you guys actually educates myself as well. So it helps me grow as an individual, it helps me grow as a person, and it helps me. So Lisa says, I love an overlay lesson. You have figured out all the widgets and connectors. Yes, I have. Give me 1 second here and I will be right back. Okay, thank you. I am back. Righty then. But yes, Lisa mentioned a great thing. Um, yes, overlay. So I use OBS. So OBS is used by mainly almost every single streamer that you see uses OBS. Some streamers might use a different type of broadcasting system, but mainly 99.9% of streamers use OBS. So I use OBS, and mainly why everybody uses OBS, one, because it's free, right? People love free, and but not only that it's free, it actually works very, very well. It's a very, very great platform, and you can use a lot of plugins. So, uh, but yes, I could definitely show how to use OBS, how to put plugins into it, how to add browser sources, how to add in pictures and graphics, and because what you see on my screen, my overlay is these are sources that are these overlays are coming from different sources. So the John Boy Severe Weather Lab that you see in the top right corner, that source comes from a picture source. That source comes from a picture on my computer. The overlay that you see in the bottom left hand corner, that's the flash flood warning, things of that nature, that comes from the website Overwarn. So that is so I have that brought in from Overwarn. So that is real time, up to date warning when it comes to that. So and then all the stuff you see, like the people on Twitch and my subscribers and the tic tac toe game, some of that comes from Streamlabs. So you guys have probably heard of Streamlabs as well. Streamlabs is the bot that is in here talking a lot. And so brother John McKinney uses Streamlabs. Almost everybody else uses Streamlabs as well. Some streamers use Stream Elements. I personally like Streamlabs. It's just a preference. Um, um, so yes, so I use Streamlabs. Again, some streamers like to use Stream Elements. I just prefer Streamlabs. That's just my preference again for that. When it comes to that. But yes, but I use OBS mixed in with Streamlabs. But so OBS is what I use to broadcast out to all of the platforms, and you can set up all of your streams inside of OBS to where you don't have to like physically go into each platform and start your stream. Once it's connected to OBS, you can just start streaming inside of OBS, and it spreads it out to all of the platforms, and it goes live on all of the platforms. So it's a good thing there. But again, yes, I use OBS to for my main broadcasting is what I use for that. So Again, OBS is what is basically used by basically almost all the streamers that you see. They are basically probably going to be running OBS as their, excuse me, as their main broadcasting system there. But again, a lot of people, and then again, you mix it in with Streamlabs, you can mix it in with Stream Elements, you can mix it in with Nightbot, you can mix it in with all bunch of different things. So I run OBS and I run Streamlabs. Those are the two things I run currently right now that help me with my streaming. So when it comes to that, and I just use a web camera. I use a web camera that has a function as with the built-in microphone, but the camera is a 4K. It's a 4K web camera. It's a Logitech. I use that, so it's a higher end web camera that I use. But again, it's a 4K web camera, Logitech with the built-in microphone. So sometimes you'll have streamers and they'll have like setup microphones and stuff, and again, that's just preference, right? And a lot of times it'll be a Shure microphone, Shure. That's very popular amongst streamers. It's a very popular brand due to its clarity and its quality microphone. So again, it's just preference. My preference is I like to have the web camera set up, and I just utilize that audio, to pick up the microphone. But again, it's preference. Some streamers like to use an actual microphone, and then I use OBS again. Like I said, I use a background blur. So sometimes when you see uh, my hands and stuff, sometimes they go blurry. Sometimes they go. It's just it's a background that blurs the background behind me. So. So that is a background blur that I use for that. Um, but yeah, and then and then you can just set up, your overlay any way you want it. But I found this is what works for me. But yeah, Streamlabs has, thousands of different overlays you can use. I mean, you can, in OBS, you can plug in different overlays. I mean, there's just so many things that you can utilize for OBS. So there's a lot of different overlays. This is just my own. Like I just did my own here. I didn't utilize any, at least the scene. They're called scenes. And so if you're not familiar with OBS, they're called scenes. SCENE. So this is a scene that I created, but I do have a downloaded. I do have a downloaded widget. That is a mental health widget, and that's why when you see me do like "Be Right Back," stream is starting soon, that is taken from Mental Health Painters. So I found that, and I did download that pack, but I created my own scene inside of that. So, and that's the scene that you see here when it comes to that. So. But yes, OBS is very strong. I mean, there's so much you can do with it. So much you can add in. There's so many different things. So like on my screen right now on OBS, like I'm looking at my outputs, which tells me that I'm streaming to 4 different platforms, and it shows me how long. I'm looking at recent activity off to my right. I'm looking at chat. Chat is up here off to my right. And then I have scenes set. I have the scene set up. I have sources set up. I have audio set up. But you can mix and match. You can customize your stream, customize your the way that yours looks like to your liking. So, but yeah, so I got a lot of that and built in for that when it comes to that, and then yeah, so I use that, and then for multi streaming, because OBS is not native multi streaming, you have to add a plugin or add a source to multi stream. So I use what's called Altium. It's Altium. I use that to multi stream to different platforms. So I could also use Streamlabs if I wanted to, but Streamlabs you do have to have I believe you have to have a membership or some sort of paid subscription in order to be able to stream to, I believe, more than two different platforms. So I use Altium again, and that is free, and that lets me multi-stream to different platforms, so without having to pay anything. So it's very very good. But again, OBS is not native to multi-streaming. You have to add in that plugin. But again, if you do have Streamlabs and if you have a Streamlabs subscription, it is relatively easy to multi-stream straight from or inside of Streamlabs when it comes to that. So that's a little bit of the OBS stuff, though. Yes, but I could easily and gladly, I would be able to show any of you guys that. I actually texted Brother John that the yesterday or the day before. I texted Brother John McKinney and told him I'd be willing to help him out with his stream, with his OBS or whatever it may be, and help him with graphics, whatever it is. I just offered my help, and if he ever needs it, he knows I'm there to help and willing to help him. And if not, that's fine. But yes, definitely offer my help to Brother John, and if he needs any help with the stream or with OBS or whatever it may be. So when it comes to that, and I'm also working on setting up, hopefully sometime this month, to set up a live stream with me and Brother John McKinney. So hopefully sometime this month, me and him will be live streaming together. Hopefully we can carve out a day and carve out a time to make that work according to our schedules. But I would love to do that this month. I have mentioned to him earlier before in a text earlier this week, and then I just texted him again just a couple of days ago and asked him that as well. Actually, no. Actually, that was yesterday. I'm getting the days mixed up. So today is Monday. So Sunday, we texted yesterday on Sunday, and but yes, definitely looking forward to doing that. I don't know what that stream would look like. I do have a little bit of ideas in mind, but if you guys have any ideas in mind that you would like that stream to look like, let me know, and I can kind of work on those ideas, and to maybe to obviously give you guys what you guys want. But I do have a little bit in mind what I think that live stream might entail or might be like. But again, if you guys have any suggestions or anything like that, please let me know, because I would definitely love to learn about maybe what you guys might like that live stream to look like when it comes to that. So, but yeah, because I know Brother John's chasing a lot. I know he's busy a lot, and I get that. We're all busy and stuff like that. So when it happens, it'll happen. So hopefully it will come to fruition this month. So this July is usually a more of a month that, especially for tornadoes, it's a down month for tornadoes typically. So typically it's more of a quiet time month. Especially as we get towards the latter part of July, we start getting into August, and it becomes more wind bag events and wind driven events. So the tornadoes start to wind down quite dramatically. Typically, that doesn't mean that they can't fire up, obviously, because they can, but typically start July, August, they becomes more duratio events and long-lived MCS events. So when it comes to that, so July and August are usually slower months for tornadoes, and sometimes in the weather community we like to call it the second season, and you guys might have heard the term too. But in the weather community, we call it the second season. The second season is basically the fall time. So once about October comes, early October, middle October, sometimes because now we're going from warm to cold, right? We're going from summer into fall. We get that second season or the second tornado season. Sometimes we do end up picking up back up a little bit of tornadoes there in the fall time due to the changing of the seasons there. So sometimes that is what is referred to as the second season. But as far as the middle of summer, as far as that, there's just typically just not the tornadoes just typically are not that much prevalent in July and in August and even into September as well. Sometimes it starts to pick up a little bit towards the end of September again, October possibly, but July and August typically tend to be slower months for tornadoes. It's just typically that's how it works because of the hot weather, more hot, more drier, not a lot of more. Um, and A lot of times it's those MCS wind driven duratio type events versus long lived discrete storm cells when it comes to that. So, but anyways, if you guys have again, if you have any inputs or maybe anything you think that stream with me and Brother John McKinney should look like, or what do you think what you would like to see, let me know and I can, jot down ideas and because again, I have an idea or have some ideas of what uh, to discuss with Brother John about and how we would make that work and make it that work smoothly and things of that nature. So, but it definitely will be whenever it happens. It will be a fun and exciting stream when that does happen. So, very, very excited about that when that does come to fruition there. So, but yes, so look forward to that. Hopefully, sometime this month. Again, looking forward to that. Looking forward to hopefully again having that sometime this month. Um, or if it falls into next month, that's great. Whenever we can get it lined up, that will be a great stream. So be a lot of fun, be a lot of cool things going on, be a lot of great things there. So yes, so just to be have a lot of great partnership there with Brother John and Pastor John. So just have a lot of great partnership and again just grow as individuals and grow our YouTube communities. And so it's really cool. It's really great stuff when it comes to that. So, but yes, so looking forward to that. Again, looking forward to just keep growing. Like I said, almost pushing 3.3 thousand. So blessed for that. So blessed for all you great moderators. So blessed for all you great, just supporters, people who are in here, constantly, people who are just bouncing in and out. That's awesome as well. I mean, the usual suspects, and all of you guys are awesome. So just very thankful for all of that. So again, yes, thank you to everybody on Twitch. Thank you to everybody on YouTube. Thank you to everybody on Facebook. Thank you to everybody on Kick. Thank you to all for being here. Thank you for all for joining the John Boy Severe Weather Lab and Education. Very blessed to help and teach you guys about severe weather. Very blessed and thankful for just to be able to be a part of just to help you guys, and help myself and to grow. But definitely hope that you guys learned a lot about earthquakes. Hopefully, you guys learned some different facts, some cool maybe things that you didn't know about before, and why that they can be so devastating for, right? Because of all the energy that is being released out there, out in the surface of the earth, and how it bubbles up, and then all the energy gets released, and it starts shaking because it has to release all the energy. So again, it's all the energy that's being released when it comes to that. So yeah, so it is very awesome to be a part of that and to grow. So very thankful for all of you guys. Very thankful for uh, just all that. So I hope you guys did learn about earthquakes tonight. So when it comes to that, so Libby says, truly appreciate and enjoy this community. Thank you, Libby, so much. I appreciate that. Very thankful for you, Libby. Very thankful. You are a tremendous sister in Christ. You are a tremendous supporter, a tremendous encourager, just everything. So definitely am very, very blessed and thankful for your support and for your encouragement. It's very, very awesome, and I'm very, very thankful for it. Um, I am humbled by all of you, and I say that every stream, and that is true. I am very humbled by all of you. I'm humbled the fact again that people would rather listen to me and rather watch me than do something else. And to me, I consider that's a very humbling experience, and I'm truly appreciative of that, and I do not take it for granted because, again, I know that all of you could be doing something else or choosing to do something else, and so I'm very thankful for that. Very uh, again very blessed, and I do not take that lightly, and I do not take it for granted when it comes to that. So very thankful. You guys are so amazing. You guys are so awesome. Just very thankful. Again, I mean, it's a very humbling experience. It's a very, very humbling experience to get on here and have people just watch you, and just listen. It's a very, I'm very appreciative of it. Very, very am. I'm glad I have this platform. Very glad I have this platform to do this and to learn. And again, I learn from you guys. And I do, and I say it every stream, and I'll say it every stream. I do. I learn from everybody as well. It's great to be a part of this community. It's great to be a part of, just all of this, and but yeah, I'm very blessed. I'm very blessed to be, marching my way to almost being a YouTube partner. I'm very blessed for that. Just very blessed, to, it really is truly awesome. It really is. And I mean, I love interacting with all of you. I love being a part of the community, answering questions, and asking and getting to know each other, things of that nature. So, um, but yeah, so that leads me to, if you are new here, welcome to John Boy Severe Weather Lab and Education. Here you will find accurate and honest and trustworthy severe weather information along with weather information and education. So not only will you find accurate data and accurate information, I will teach you as well and educate you as well on the severe weather as well. So very thankful. Welcome to John Boy Severe Weather Lab and Education. My name is John. My nickname is John Boy. I have had that nickname ever since I was a young kid, and it is also my son's name, John Boy Jr., and I am John Boy Sr., so that's what we go by. But yes, John Boy is my nickname. My real name is John, but very thankful that you guys are all here and part of the John Boy Severe Weather Lab and Education. So very thankful for that. Again, thankful to everybody on Twitch. Thank you to everybody on YouTube. Thank you to everybody on Facebook. And thank you to everybody on Kick. So that leads me into this. It was very hot today in Chicago. It was about 92, 93 degrees. How was it in your neck of the woods? What was your guys' temperature out there today? Mine was pretty stinking hot when it comes to that. So let me know. Let me know what it was like in your neck of the woods today. Yeah, so let me know. Let me know how it was in your neck of the woods. Let me know. Today in Chicago was about 92, 93. Let me know kind of what your temperature was today for you over there. Very interested to know what it was over there for you guys. Sonia says 79 degrees. Libby says, I think it was in the 80s, but I didn't seem bad. Lisa says within the 90s. I had to get the phone to verify. Yeah. Yeah, it was warm here in Chicago. Yeah, it was like 90, like I said, about 90, was it 93 or something like that? 92, 93. So, yeah, it definitely was pretty warm today um, over here in Chicago. So, when it comes to that. So, Lisa says, I did a walk outside today while listening to a sermon just to remind myself that I am very blessed to have AC that works for. Yes. Oh, amen to that. Amen to that for sure. That is, yes, definitely amen to that. That is, yes, AC, man. What a luxury, right? Well, AC is definitely a luxury. Because when I was outside, when me and my wife, we went out, ran to the store earlier today, and we came back in from being outside. And when we came in from outside, it was like, man, it was just a luxury to not be sweating, and a luxury to not feel sticky, and a luxury to not feel. It really is, right? AC is it's very awesome. So, um, so definitely very thankful for definitely thankful for AC. Uh, so I don't know, and I've lived without AC before. Like I've lived in like when I was younger. We didn't have AC before. We just had like raise your hand if you've ever just had a box fan in a window, because I know what that feels like, and that does not cool anything down. It actually, to me, I think it just circulates and puts warm air in the place. But I remember box fans in the window, just fans all around. But yes, I definitely AC is definitely awesome. That's for sure. So, but it's awesome. Uh, yes, Lisa says, "Yep, the box fan that we made funny voices in front of." Yes, always doing like the Darth Vader voice and just all the cool stuff you could do with the fan and everything. So yeah, the box fans, man, box fans were cool for that. Um, definitely. But yeah, Lisa, hopefully, let me know what type of sermon you were listening to if you want to. If you want to fill us in and let us know what kind of sermon or type of sermon you were listening to today, please let us know if you want to share. Sonia says, never had AC. My roommates have AC in a travel trailer, but won't let me use their separate AC unit since I'm in main house. Wow. So you don't. Well, I don't know because you're in Northwest. Um, you're in Northwest Washington, I believe, right? Or you're somewhere in Washington. So, um, so I don't know. Maybe so. You do you not need AC then up in that area? I don't know. I don't know. It seems like it would get a little bit warm though. Libby says we don't have AC, but have a lot of big trees, which helps, and we have some fans here and there throughout the house. Okay. And Libby, correct me if I'm wrong. I don't know where you're at. I don't think. Maybe I just maybe I don't remember. Uh, for some reason, Ohio's sticking out, but maybe I'm wrong in Ohio. I don't know. Uh, I see so many um, different things in here. Okay, Lisa says she listened to um where'd it go? It was from where can I find it? Oh, it was from Grace Church in Des Moines on Psalms. Nice. Awesome. Psalms is an awesome book. That's awesome. Oh, okay. Oh, that's right, Sonia. I do remember that. Yes. So you live very close to Canada then. If you were 30 miles north of Seattle, you're like really close to Canada. Uh, but Sonia says it gets very hot in my room since it faces west. Yes. Uh, I live about 30 miles north of Seattle. Okay, yep, remember that. Yes, if your room does face west or your windows, are facing west, it is most likely to get the most hottest because that is where the sun is going to be at its most. Because obviously the sun sets in the west, uh, but it's at its peak and stuff. Um, 2, 3 o'clock, 4 o'clock, and it's going to be pointed in the west there. So that's why if your room or windows facing the west, it's going to be the hottest spot in the house. Libby says, I'm in Michigan. Okay, I am familiar with Michigan. I well, when I lived in South Bend, Indiana, very close to Niles, Michigan, Benton Harbor, things like that. Um, so very very familiar with like southwestern Michigan. I know like I know Paw Paw, Michigan. I know Lawton, Michigan. Sister Lakes, Michigan. Um, but besides that, I don't really know much outside of that in Michigan. Libby says, I also close the drapes when the sun is shining. Yes, yes, because our room, mine and my wife's bedroom, our bedroom faces the west, so our windows face the west. So a lot of times on hot days like today, and our room being upstairs, and as you know, heat rises. So a lot of times we do keep our curtains closed as well, just to keep the sun, this heat of the sun from coming in as well. When it comes to that, so. Uh, but yeah, it's definitely. If your room faces the west, you would definitely know when your room is facing the west. So it's very. But yeah, but if you have trees around, that's great. If you have like natural shade, that's great. That's awesome. But sometimes there just isn't any natural shade or natural. Um, to help block the sun and keep it cool when it comes to that. So, but very cool stuff. Very, very great stuff when it comes to that. So, and for those of you who you don't know me, if you are in here, again, I am. My name is John. Again, I go by John Boy. So, welcome to uh, John Boy Severe Weather Lab and Education. Thank you for being here. We are now into the part that is called Fireside Chats, where we sit and chat about anything and everything, and have Q&As and everything. So, welcome to the Fireside Chat segment of John Boy Severe Weather Lab and Education. So, thank you so much. I think I just missed something. Let me see. Lisa says they started the sermon series in Psalms and talked a lot about David and his tribulations. Awesome. Uh, awesome. Great. That is so cool. And I don't think I asked a question. And if I did, I don't remember. But if I did ask a question, how many of you actually have felt an earthquake before? I mean, Sonia probably has, and probably from being from the West. Uh, but as far as I know, I have not. I don't recall ever feeling anything like that. So, as far as I know. So, but how many of you have? Lisa says never felt one. And again, that's Iowa. So, I don't know if you've been in Iowa your whole life or not, Lisa, but Lisa still says never felt one. Libby put the smiley face, so I'm thinking, yeah, is that a yes? I think maybe that's a yes then for Libby. Yep, Libby says I've felt two. Okay. Um, Lisa says we supposedly have had aftershocks, but I haven't noticed them. Okay. Yeah, I don't know either because I'm not 100% sure if I ever have. So, Debbie says not in Raynell, West Virginia. So Debbie is off in the east there. Uh, we're talking about feeling Omni. If you've ever felt an earthquake before, uh, Sonia says 7 to 8 earthquakes. So Sonia is the earthquake winner. Uh, but again, Sonia is over there on the West Coast. So, okay. Libby says the smiley face was for Omni. Okay. Thank you, Libby, for that. But yes, wow, Sonia, that is quite a bit of earthquakes. Omni says, I've been in two when I lived in California back in 2006 to 2010. Okay. Awesome for that. Awesome. Yeah, as far as I can remember, I've never been or never felt an earthquake. Um, since Sonia has been in 7 to 8, Sonia, what does it, or somebody else can jump in too. What is the feeling like when you do experience an earthquake? Thank you, Libby. I appreciate that. Thank you so much. Oh, Omni is a Michigander too. Omni is from Michigan. My mom and dad have felt two here in Michigan back in 2016, I think it was. Okay. Omni says 4.5 and 4.6. Okay, so that's decent size. Quakes near Kalamazoo. Okay. Sonia says the last one I believe is 19. I heard it coming across the valley where I lived at the time. It was weird to hear it coming towards me before it actually started shaking. Wow. That is wild. That you could actually hear it coming at you. That's like something out of the movies or something that you would like see. That is wild. When it comes to that. So, uh, very awesome though. When it comes to that's wild to me. Very wild to me. Uh, to see that. So when it comes to that, um, but yeah, very man. That's yeah. To have it become to have it come at you like that. That's wild. So, um, so it looks like we got two Michiganders in here. We got Libby and we got Omni in here. Um, we got Iowa with Lisa. We got Debbie in West Virginia. We got Sonia in Washington. We got people all over, which is awesome. Very awesome stuff. What did I just let me see here? Uh, Sonia says the Nisqually earthquake in 2001 was 6.1. I'm sorry, 6.8. 6.8, and her floor was rolling in the kitchen. So 6.8 is considered strong. She was almost in a what they would consider great. So 6.8. I like to look that up. I'm not familiar with that. So, but to see your roll or see your floor rolling, that would be wild to witness. That would be extremely wild to witness that. So, when it comes to that, did you have stuff falling over too? Did anything fall over, Sonia? Anything break, fall over, do whatever? When it comes to that, that would be pretty. That would be pretty wild. So, Sonia says, honestly, I would rather not hear it before it hit. It happened at 3 a.m., so it was very creepy. That would be like the movie. As someone who gets motion sickness easily, I can't imagine the floor rolling underneath me. Yeah, that would be wild. That would definitely be extremely wild. To have that. So, uh, Lisa asked a great question though. Lisa asked, "Are there any building codes for a ring of fire area for residential homes?" That's a great question because you would think that if you are earthquake prone area, that maybe your house might be built to a stronger standard than a house being built in, you know, Florida or somewhere. I don't know, just saying. So, Sonia says, Sonia says, I had some wooden geese high up that fell over in earthquake. I had two cockatiels at the time that were thrashing hard and were trying to stay calm. Them, oh, we're trying to calm them down so they didn't get hurt. Oh wow, yeah, Lisa, that's a great question. That's a very great question. It's kind of like if you live in Oklahoma and stuff like and Kansas and stuff, it's like shouldn't your house probably be built uh to some other standards to withhold or withstand like EF4, EF5 damage or something? I don't know. I know there are supposedly houses that can be built that they say, oh, well, this house built can withstand 250 miles an hour. Or they can. There are companies that put stuff out there like that. Um, so I don't know. Um, when it comes to that, that's a great question, Lisa, because definitely if you're definitely out there in the Ring of Fire area, you would hope that you're, especially in the United States. Now, when you get into the less the less more places like like Indonesia and places that are maybe less what do I say uh, maybe they don't have the strongest structures built and things of that nature. um, you but you hopefully here in the US, hopefully we have some stronger codes that for things being built. I don't know. That's a very great observation. When it comes to that. Very great observation. Because yeah, it's just yeah, it's definitely because you definitely would want to be in a sturdy building, um, when it comes to that. So, Libby says Michigan homes have sturdier roofs because of our snow. And I know from experience because I used to live in South Bend, Indiana. So if anybody knows where South Bend, Indiana is, it's in the north central part of the state, almost due north, just below the Michigan line. Um, so being to the east of the lake of Lake Michigan, we would get hammered with lake effect snow. So not only would we get system snows, we would get lake effect snow and a lot of it. So yes, definitely, I could definitely see what Libby is talking about as her being from Michigan, obviously off to the east, unless she's in the UP, which I don't think you are in the UP. So you probably are off to the east of Lake Michigan, um, nonetheless. So when it comes to that, but yes, yeah, but when I lived in South Bend, we would get um, hammered with lake effect snow, and even a place called LaPorte, Indiana, too. LaPorte, Indiana, which is it's too, which is sits to the southeast of Lake Michigan. Lake effect snow quite a bit. But yeah, I don't know if any of you um, have ever been a part of lake effect snow or witnessed lake effect snow. But lake effect snow can be there can be some very intense squall lines, some very intense heavy snow that will whiteouts, blinding, like you can't see nothing, you can't see anything. So lake effect snow can be very dangerous at times. So even here in Chicago, we do get lake effect snow, but it's very rare because we're on the west side of the lake. So a lot of times what that means is we will get the backside of the storm, the backside of the storm system when the storm's wrapping around and it comes from the backside. So then we'll get the winds out of the north, and so it'll be coming and blowing south across the lake. So when they're blowing south across the lake, that's when Chicago will get some lake effect snow. So yes, we do get some lake effect snow in Chicago, but it's not as prevalent as it is off to the east due to the winds. So when it comes to that, because the winds out in front of the system are going to be blowing east, and mainly they're most likely going to be blowing usually northeast, maybe sometimes due east as well. So that's why you get a lot of lake effect off of the lake there, and that sometimes they'll also be blowing southeast as well. So um, that's why you get the lake effect snow there. So uh, Libby says lake effect snow is a snow that is more moist. It can be, yeah. It can be heavy at times, but yeah, it's created. It's created because the lake is warmer than the air around it. So the winds that come over the lake are colder than what the water is. So that creates the lake effect snow. Um, but yeah, so lake effect snow though is uh, I guess yeah, maybe you could say that. But nonetheless, it is it can be very heavy as well too, when it comes to that. So, just besides system snow as well. So, um, but yeah, definitely we would get a lot of system snow, a lot of lake effect snow, a lot of snow. So, uh, Libby says it drives differently than a dry snow. Okay. Drives differently than a dry snow. You mean like wind? I'm trying to think. Hits differently too. Yeah. Trying to think. I'm trying to understand that. Libby, I just want to make sure I understood that correctly. Um, by that, so. But nonetheless, yeah, lake effect. It can be very, very dangerous. It can catch people off guard pretty quickly because it can form pretty quickly. With that, so Sonia says, Lisa, I can say that in order for my mom's 76 single wide mobile home has to be strapped down in order to get earthquake insurance. Oh, I did not know that. I did not know that. Not was aware of that. Not was aware of that at all. Thank you, Sonia, for that information. Appreciate that. Thank you. Thank you very much, Sonia. Oh, when driving in it, it can. Yes, yes. Thank you, Libby. Now I understand what you were saying. Yes, thank you. Apologize for that. Yes, definitely slushy snow. It just I don't know. You if you've ever driven in snow, it just completely sucks. So uh, when it comes to that, so um, I've driven in so much snow, slush, ice, deep snow that it just sucks. Yeah. But sometimes it's got to be done. And you can imagine, um, Sonia says it's not cheap for a mobile home to get strapped down professionally. Okay. And by strap down, like, do you mean like strap? Like, how do they strap it down, Sonia? I'm not familiar with that process, but I am interested to know. Uh, I'm interested to know um, what they do there with that. Thank you, Libby. Appreciate that. Um, but yeah, I have driven in sleet, slush, snow, hail. You know, uh, what do you want to talk about? Ice. Um, you don't ever want to drive in ice though. Ice is horrible. I mean, you don't ever want to drive in. You know, it's could you imagine, especially here in Chicago? Can you imagine this is the third largest city in America, and the freaking traffic is just absolutely out of this world. I mean, just absolutely ridiculous. I mean, and I'm not even talking like going into the city. I'm talking like in the suburbs and way outside of the city. And traffic is just so you can imagine that all the interstates that are around right here. imagine those being filled with snow and ice and everything. Imagine just how wild those interstates get, and they get really wild. So, Sonia, I imagine not. That would be a difficult task. Yeah, see, I definitely think it would be too. I'm interested to know though, like what that process looks like what that means exactly, because I don't know if I've ever heard of that. Oh, Sonya. Okay, good. Sonya says it's kind of like you would cinch it down to straps onto a vehicle onto a flatbed. Okay, let me see. Keep coming. Where'd it go? Where'd it go? Where'd it go? Uh, a vehicle into a flatbed tow truck. Okay, got that. Okay. Libby says ice is tricky. Yes. I don't know how many of you all have ever been to a big city, like maybe Chicago or um, Detroit, uh, Los Angeles, New York City, whatever. But if you've ever driven in um, like around Los Angeles, around New York City, around Chicago, that it just is absolutely ridiculous. It is absolutely ridiculous. I used to drive around LA, like around on the freeways, and it was just complete, just wild, just like Chicago here. Oh, you did a great job, Sonia. Thank you very much, Sonia. No, you did really great, Sonia. Thank you very much. Yeah, it takes and it probably does take quite a bit of uh resources to tie one of those things down. So uh Debbie says yes. I went through 3 states back in April to get to Wisconsin. Yeah, yeah, yeah. I used to drive around the freeway. Like I used to drive around the freeways there in LA, and that's just completely. I thought Chicago. Now there is traffic, right? And then there is LA traffic. I've never driven in New York City, so I can't speak on New York City traffic, which I've heard that is like the nightmares of all nightmares. But nonetheless, when I would drive around to LA traffic and the freeways on LA, with all the roads that are there, with all the freeways that are there, you would still get backed up. I mean, there was just no way of getting around it. And six lane highways, and uh, you're still getting backed up. And in Chicago, you're still getting backed here, and we got we got I-55, we got I-57, we got I-94, we got I-90, we got I-80. We got like 5 or 6 or 7 different interstates. We got I-355. We got all of these highways and interstates, and you get on these things, and you're still backed up, and you're still stuck. And sometimes they just become parking lots. And what that means is you just stop on the, you're just stopped for like a minute or so, just in traffic, just on the interstate. They just become parking lots, and it gets wild. Definitely gets wild. So Sonia says, "No problem, John Boy. I'm not always the best at describing." No, I appreciate it, Sonia. It's all good. You did it. It's all good. I appreciate it. So, um, and the thing about Chicago here is you have to pay for a lot of those roads. When it comes to that. So Libby says, I avoid cities as much as possible. I have driven in Chicago, Detroit, and Memphis, but only from necessity. Sure, definitely. I've never been to. I've never driven in Detroit, and I've never driven in Memphis, so I don't have any experience with that. But I have a ton of experience in Chicago, and again, it is um, very, very wild at times, to say the least. Um, Lisa says, so many toll roads around Chicago. I had PTSD from just being a passenger in NYC. I would assume so. I've heard that is like um the worst of the worst. That's why I guess most people in who live in like the actual, New York City metropolitan area, they actually like don't even drive. They just either use city transportation or they use bikes or whatever else, just because driving, you're basically gonna get nowhere and drive with driving. So Libby said Detroit in a snowstorm where you couldn't see. Let's see what she said. Couldn't see the lanes or order cars. Yes, I definitely know how that goes, and that sucks. Definitely sucks. So, uh, but yes, uh, yes, here in Chicago, every freaking road is basically a toll road. So they're not freeways here; they are tollways here. Um, Tons and tons of tollways. Um, just all over the place here. Um, Lisa says I'm the odd one. She loves driving in snow. Yes, Lisa, you might be the odd duck, but that's okay. Someone's got to be the odd duck. So it is you, Lisa. Uh, Sonia says, in all the years I've she says, I've only driven in Seattle twice. I have actually only driven in Seattle once. I went out there on a business trip. And um, I, obviously I rented a car, then drove around. But thankfully, I went to what is it out there? It's the big thing. Um, I think it's the Needle, right? Space Needle. I think it was that because I went up it and then I went on top of it. So I think it was a Space Needle. I think is what it's called. So, but somebody correct me if I'm wrong. But I think it's called the Space Needle. Um, Libby likes driving in the snow too. So it looks like Lisa and Libby um, can be snow driving partners together when the snow starts. So Sonia says, Lisa, I love driving in snow. I get it from my dad. My mom is the one that freaks out. Yes, there are a lot of people who do freak out in the snow when it does snow, for sure. So Lisa says, yes, it can be fun as long as there aren't a lot of idiots on the roads with me. That is the hard part because you don't know. Um, you just don't know who's out there on the road with you. Sonia says, yes, Space Needle is in Seattle. Yep, that's what I went up. Yep. It was pretty cool because uh, when I went up it, and I don't know if it still is like this to today, but this is only like 4 years ago. I went up it, and um, like the floor is rotating, so like the floor is rotating, it's glass, so you can see underneath you and stuff. So it's pretty cool, and then you could go outside it and stuff. So you ride an open elevator, or not open, but the glass it's glass. It's a glass elevator that gets you up there. So it's pretty cool. Actually a pretty cool experience. So uh, there. So, but that's the only time that I've ever driven around Seattle there and stuff. So um, what did I see here? Um, Lisa says I rode the Ferris wheel there, Sonia, and had a panic attack at the top. Oh wow. Uh, Sonia hates heights. Yeah. Yeah, the Ferris wheel to get stuck on a Ferris. Or did you say you got stuck, or you just rode it? I didn't see. Because to get stuck would be one thing, that's for sure. Oh no, she just had a panic attack at the top. Okay. Well, that sucks, Lisa. That very sucks. About about your Ferris wheel experience for sure. Yes, Lisa, you and Libby should be. You guys can be snow buddies and storm chase snow uh, and be storm chasers together with that. So uh, so it's like you and Libby can tag team. Lisa says, "I found out just how afraid of heights I really am." Yes, if you are afraid of heights, which it's there's millions of people who are afraid of heights, millions of people. Um, I myself, I am not a fan of heights either. Like I don't do well with heights myself either. I am not the hey, let's go to Cedar Point, hey, let's go to Great America type of dude. Like I'm not like, hey, let's go ride like, 12 roller coasters today. That's just not really what I'm into. I'm not into riding like being on roller coasters and going up, 300 feet and then flying around and that's just not really me, but um, so I'm not really a big fan of heights myself either. So, but I don't mind flying. I actually enjoy flying. I actually like flying. So, but when it comes to like other things like roller coasters and stuff like that, I get little timid, stuff like that when it comes to that. So, um, but when it comes to flying, I actually enjoy flying. So Livy says, agree, not a fan of heights. Guess that's why God made me the short one of my family. That's awesome. What was that? What did I just see? Lisa said, so no slingshot rides in your future then? Not for me. No slingshot rides for me. Um, no Ferris wheels for me. No, none of that for me. So, but I mean, I will like if they have a good time and stuff like that. But it's just not my first choice to like, hey, let's go, uh, ride roller coasters and slingshots and and all that stuff. So that's not my go-to. So Lisa says, I'm sorry, Sonia says, Lisa, I have been scared of heights since I was a kid. My dad held me off the grassy cliff. My dad held me off the grassy cliff next to Deception Pass here in Washington State when I was a kid. Oh, wow. Well, sorry to hear that, Sonia. That's pretty deep. That's pretty, man, sorry about that. Yeah, that's wild. That's wild. So, very sorry about that, Sonia. Um, yes. Yeah, sucks. That sucks to hear, Sonia. Sorry about that. Um, Debbie says, "Don't eat before you go on any rides because it will come back up." Yes, most likely. Most likely it will. Yes. But I have been to Cedar Point. I have been to Great America. Um, see, I have been here. Oh, I shouldn't say here because I'm not in Indiana. But in Indiana, we would always go to a place called Indiana Beach, which is a pretty cool place. I would definitely recommend going there. Um, Sonia says, I was so upset with my dad for that, then he wondered why I was scared of heights. Oh, wow. Oh, wow. Thank you to everybody who is watching on Twitch. Thank you to everybody who is watching on YouTube. Thank you to everybody who is watching on Facebook. And thank you to everybody who is watching on Kick. You guys are all awesome. Thank you guys so very much for being here, for for trusting me, for being part of John Boy Severe Weather Lab and education. Just very, very thankful for all of you being here. You all are pushing me um, in several ways uh, for greatness and for success across multiple platforms. Thank you guys so much for that. Very, very thankful. Very, very thankful for that. So, but yes, very, very thankful for all of you. Yes, thankful. Yes, very thankful, very blessed for all of you again. It's just I love these fireside chats. I love Q and A's. I love, uh, the topics, obviously, but definitely love these fireside chats and Q and A's about everything. So, but yeah. But to get back to Brother John, I'm very very excited. For Pastor John, Brother John, um, to be out there in the East tomorrow. That is pretty cool. Um, According to what Lisa said earlier. So that is really awesome. So very 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 cool to see that. So very thankful uh, that he's going to be out there doing that. So that is very cool. So oh, Lisa says he is flying out there. Okay. Do you know if he's meeting up with anybody out there, or is he Jason by himself, Lisa? She posted it. I did not see that. I looked in the Discord. Was that must have just been a little while ago or something then? Because I was looking in Discord earlier today and I didn't see anything. So Melanie didn't say. Okay. Hmm. I guess I could just text. I guess I could just text him and ask him. But I didn't know. So yeah, I looked in. I guess I looked in there. It must have. I looked in there a little bit before I came online. So oh, and maybe it's in the mon. Oh, you guys had two channels. You guys had two Discords. Because if so, that would make sense. Because I didn't unless it is in the main Discord. Uh, but yeah, but maybe it did come across. Maybe it did come across. I don't know. I'd have to look. Let me look. I'm gonna look right now. Let me see. Yeah, I think that was in the. I think that was in the mods. Was that in the mods then? 'Cause I don't see it in the main. I don't see it in the main. In the main Discord, unless I'm not looking in the right spot. Let me see. Oh, okay. So that must be, yeah. That must be in the main in the mod one then. Oh, I don't need. No, I'm not a mod, so I mean, I don't need permission. I don't want to uh jump on step on anyone's toes or anything like that and stuff. So whatever permissions I'm allowed, I'm cool with. Whatever ones I'm not, that's awesome too. So um, but yeah, but either way is cool. So it looks like we got Chasing for a Cause is in here. Thank you for joining, Chasing. Great to see you. Thank you for your support and for your encouragement. Uh, Appreciate that very much. So, very thankful for that. So, um, when it comes to that, so hopefully everything is going good there for you, Chasing. Um, so I'm thinking if Brother John is Pastor John is going to be um tomorrow, Chasing tomorrow, because he's not going to be in his vehicle. So he's going to have a rented vehicle. So that means he would have to have his in-car setup with him. Um so yeah, it'd be a little different, but he can definitely make it work, obviously. So hopefully, yeah, he may not. I mean, it probably just have the essential to just um because I don't know what the yeah, I'm not familiar with like what kind of reception he would have up there. He would definitely have to have a bonded connection for sure. Uh, when it comes to that, so chasing for a cause says so. Well, hopefully your day gets a lot better. Chasing, uh, don't know. Oh, are you in the Kentucky area? Is that what it just says here? Or am I seeing something here? But nonetheless, wherever you're at, hopefully it gets better for you there. So, but thank you for joining in. Yes, Lisa says going to be so many trees. Yes, it is going to be an absolute tree fest up there and hills. It's going to be, yes, very, very, uh, definitely be something quite different for sure. Uh, Banger, I am not for sure. That's a great question, Lisa. I am not for sure if that's where he is from. Yeah, Maine. Yeah, anytime you get up in those types of regions, so regions, right? Dixie Alley region, Alabama, Mississippi, those all become tough too because of um, the types of elevation changes, the trees, things of that nature. But when you go up into far northern New York, Vermont, New Hampshire, Maine, you are getting into a lot of dense woods, a lot of dense forests, a lot of trees, a lot of hills. You're getting to a lot of mountain type esque places. You're getting into a lot of elevation changes as well. And as Omni points out here too, probably the not best of road networks either as well. So definitely, definitely it's going to be something different. That is for sure. But yeah, definitely going to be a lot of trees. Definitely going to be a lot of things in play like that. So um, definitely a lot of curvy roads, back roads. Probably not very good road network uh, when it comes to that. So, but there is an enhanced risk. There was an enhanced risk earlier, um, so there is an enhanced risk already out. Uh, At least it says, and no flat 1 square mile road system. Probably, yeah, definitely no flat roads out there. Definitely not your normal flat road that you would see out in Kansas and Oklahoma and things of that nature. So uh, definitely could definitely be challenging tomorrow for sure, especially if you don't know the road network and especially if you're not from the area. So that could definitely be challenging for anybody and for everybody chase like that. So, but I think it's pretty cool. He's going to be up there. It's pretty going to be pretty awesome if he's going to be up in the. Um, but who knows? Maybe he'll be with somebody. Maybe he'll be with Freddie. I don't know. He might be with Freddie tomorrow. You never know. Maybe it'll be a surprise. Maybe Freddie's on. Maybe Freddie's on a flight out there. I could see them chasing together. I could see them chasing together tomorrow, unless Freddie posted that he was doing something else. But I think they are going to go where the storms are at. So I could definitely see them doing a father son combo tomorrow. Who else? Who else thinks they could be doing a father son chase tomorrow? So, because I think they think they could be. It's possible. Yeah, because I'm thinking if, like I said, unless Freddie posted something on his socials on his social medias or something, but I haven't seen anything today come out from him. So, oh, maybe he is. Maybe he is chasing. Maybe he is still in Canada. I know he was there for those 2 days. I didn't know he was staying for a week, but he might be. Maybe he said that. I'm not 100% sure. But maybe he did. So, but yeah, definitely. But no, maybe he's meeting up with somebody else out there. Maybe he's gonna have a co-pilot, with him. Maybe he'll be solo. I don't know. Oh, Chasing says he had something on his stream about it. Okay, that's cool. Because I know him and Garrett were up there, and Garrett is if you guys don't know, Garrett is Storm Runner Media. That's who Garrett is. So he had Garrett with him. I know the other day up there, um, helping him. They were kind of tag teaming that together there. So when it comes to that, Jason says they change all the time. Yeah, Freddie usually has Eli with him. Eli is his best friend slash videographer. Um, Things of that nature. That's who Eli is to him. Sometimes, and then sometimes he has. I can't remember the other guy's name. Charlie, I think his name is. Um, I think he sometimes has Charlie with him as well too. Um, Yep, Jason process. Yeah, sometimes I have Charlie with them. Yeah, Charlie Bordeaux. Yep, and then so yeah, but yeah, usually it's him and Eli and Charlie. Sometimes it'll just be him and Eli, but usually mainly he'll definitely have Eli with him. But sometimes Garrett as well. Sometimes Stormrunner Media will be with him as well, and sometimes he will just go old school and go solo by himself. But as you know, solo chasing is very difficult. It's actually the most difficult because you're doing all the task all the time. You're doing navigation, you're doing visual scene with your eyes, you're doing utilizing all your senses, you're driving, all that. So it becomes extremely hard um, if you go solo. So with that, Debbie says, and sometimes Alex. Okay, yeah. Chasing for cause says I'm solo. Yeah, solo is it is the hardest, but it is the best way to learn too. But it is the hardest way to do things because you have to do it all, and you have to do it all pretty quickly. Not to say that it can't be done because obviously people do solo all the time, but again, uh, it is the most difficult of things to do. So especially if you're taking photography, especially if so you're moving the camera around, you're taking pictures, you're navigating, you're driving, you're looking at everything. Uh, yeah, so you're monitoring, not only are you monitoring all your gear, you're monitoring the radar, you're monitoring with your own two eyes what's going on. So, yeah, definitely, it's harder to chase solo than what it is with somebody else in the vehicle with you because uh, if you have somebody in the vehicle, you can split up the duties, right? You can have that individual be a videographer, be a navigator, be able to do other things as well, to where you don't have to, where you can just focus on certain things, And again, yes, you definitely have to be good at multitasking. Uh, But yeah, it is more difficult because all of that is on you as solo. So, uh, Sonia says I can multitask to a point, but to be honest, I couldn't chase solo if I chase. Sure, it is a lot. I mean, because you're doing everything again, and then imagine when you get. Um, I'll get into that in a second. Chasing says, luckily, I just run one camera right now and two phones. There you go. Definitely start like wherever you're comfortable at, whatever you're comfortable doing for sure. Um, because obviously safety is paramount, so you have to make sure you are safe, right, and you are safe to others around you as well. But again, your safety is paramount, right, and other individual safety is paramount around you. So storm chasing is a lot of multitasking, especially by yourself. Um, because when you watch Pastor John's streams, you can see he's got radar pulled up, right? He's got navigation put in to one of his phones or one of his devices. He's got if he's live streaming, right? Well, obviously he's live streaming, so he's got chat pulled up. He's got cameras. He's got either a phone. I think he's got two phones. So he's got a lot of stuff that he's got to be um, in charge with, and uh, making sure that he has obviously all that all together. So it is a lot of multitasking and a lot of just keeping everything up to date. So then obviously he's driving, he's looking at everything around him. So not only that, he's looking at the camera, he's looking at the radar, he's looking at all that stuff. So again, chasing solo, it's usually how everybody starts out. Majority of the time, that's how everybody starts out, is just getting in their vehicle and just going and doing it. Um, and and then they just learn from there. Um, but yeah, chasing for a cause says, or I don't take my Chromebook with me or my tablet. So a lot of times, storm chasers will use an iPad or a tablet or something for radar, something that's got a bigger screen, for the radar or something like that. So, um, and Lisa says, all that time in the car and on the road in a car, I would be lonely. Sure, definitely. Thank you, Reggiani, for subscribing. Thank you so much. Appreciate you being here. Thank you for subscribing. Definitely appreciate that. So yes, making my way again close to 3.3 thousand. So definitely appreciative of that. Oh yeah, definitely. And it is also no, you are right. It is a risk taking somebody with you. Um, Clearly, that's always going to be a risk. And then yeah, but definitely it could be a liability, right? Definitely could be a liability because you don't know how somebody may or may not, or, might act and react to storms. How somebody's going to react if there is a tornado 100 yards away from them and it's tearing up and doing damage. You don't know if they're going to freak out and just start losing it. And there's, and of course other reasons as well, but so there's a lot to go as into choosing the right individual to go along with you. Uh, but it definitely can be a huge liability for sure because you don't know if that person is either going to hold you back or push you forward. So when it comes to that, because a lot of times people just aren't built uh, to see tornadoes that close in person, or not even that, just to be up close to storms. Because usually people hide, right? Or people not hide, but people take cover from storms. So when you're a storm chaser, you're not taking cover from that storm. You're actually out there, chasing it. So it takes a different type of person to go out there and do that. And a lot of times people just aren't built uh, to be that close to hail, to be just being beat up by hail, um, to all that, so you have to, yeah. So choosing your partner, your chase partner, is definitely has to be chosen wisely uh, when it does that. So, um, but yeah, definitely, somebody can be a liability, especially because again, you don't know. Especially if that person doesn't have any chase experience themselves or whatever it may be. Again, you don't know how they're going to react if they get into a very hectic, volatile situation. They could actually end up hindering you or harming you in that process uh, because you don't know how someone's going to react. Um, and some people will freak out. Some people will freak out. Like, freak out. Like, just freaking out. Start freaking out. And you can't have somebody freaking out like that when you're trying to drive and you're trying to navigate and you're trying to maneuver. And it's just going to be bad for everybody. So, um, when it comes to that, because Sonia says safety first. Yes, it is. That's why having a if you do have a partner, you got to have a partner who's going to obviously, uh, safety number one, safety paramount, right? And that. So, but yeah, so very, 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 it's gotta, yeah, it's definitely can be definitely be a liability. So, Lisa says, I need to hop off and get some sleep. Thank you, Lisa. Thank you, everyone. Great community. Thank you, John Boy. Appreciate it. Thank you, Lisa. You're awesome. Thank you for joining in. Thank you for um, just everything. You are amazing. Hopefully, see you tomorrow on Brother John's stream. So appreciate that. Thank you so much. God bless you, Lisa. Appreciate that so much. Thank you. and chasing for causes and get along. Yes, because there can be some friction there, right? If somebody, especially if you say, hey, you're going to be the navigator or whatever else, you got to trust somebody. If you say, hey, you're going to navigate, you're going to point me in the right direction, um, whatever else it may be, and then they put you 2 miles away from it, or they do whatever. So you got to, yeah. So there can be some friction. There got to be someone you trust. It's got to be somebody to get along with. But you could definitely end up causing some friction there, for sure, depending on responsibilities and things of that nature. So when it comes to that, so it's not easy. It's not an well, it's definitely got to be somebody again, uh, yeah, who you can get along with, and for that as well. And of course, yes, and of course, yeah, because you're going to be in the car with them for hours and hours. So when it comes to that, because once you're in the car there, I mean, yeah, you're going to be riding, pretty much the whole time, So when it comes to that, so but again, like to welcome everybody in from YouTube, everybody in from Twitch, everybody from Kick, everybody from Facebook. Thank you so much for being here. Thank you for being here in the John Boy Severe Weather Lab and Education. Thank you so much. Definitely appreciate all of you. All of you are awesome. Each and every single one of you. Tonight's topic, for those of you just joining, was on earthquakes. So, learned a lot about earthquakes, the science of them, the destruction, how they form, where they form, why they form, things of that nature. So, just a great topic and great weather session on earthquakes tonight. So, very thankful, very happy to teach you guys about earthquakes when it comes to that. So again, that was the topic of today's weather session from that. So very thankful for all of you. I am going to end my stream here in about 3 minutes. So very thankful for all of you. Very thankful, for all of your questions, for all of your answers, for such a great community. Just you guys are just so awesome. Thank you for spending your time on a Monday night with a guy like me. Appreciate that. Appreciate your guys' trust, all of your guys' enthusiasm, your support, for me, your encouragement. Appreciate you trusting in me to be an accurate and reliable source of severe weather and weather information for you guys. So I definitely appreciate that. Definitely appreciate, just thankful that got to learn some cool facts about earthquakes. Got to learn some of the 20th of the largest earthquakes, in the world that have ever happened. 20 of the strongest ones. And again, if they're talking about a 9.0, a 9.0 can or 9.0 and above, that is basically like an EF5. That is the worst of the worst when it comes to earthquakes, and to just compare it to tornadoes. So very cool stuff that we learned tonight. Again, very thankful for all of you. You guys are awesome. You guys are all amazing. You guys are very awesome. So thank you to all the mods. Thank you to all of you. Thank you to Debbie. Thank you to Libby. Thank you to Lisa. Thank you to Sonia. Thank you to whomever else. If I missed, I apologize. But thank you for chasing for our cause, for being here as well. Thank you to everybody, for joining in. Everybody on Twitch, everybody on YouTube, everybody on Facebook, and everybody on Kick. Excuse me. And before I sign off here, Sonia has a great point out. Sonia says, I should have mentioned this earlier, but for those of us on the West Coast, there's an app called My Shake that alerts you to an earthquake before it happens. Okay. Wow, My Shake. Never heard of it. Thank you for the great information, Sonia. Thank you for that. That's really awesome. Really, really cool stuff. But again, yes, and I did update my bio, so my bio does have uh, my business email in it. So if any of y'all have questions, comments, concerns, anything else, uh, my email is in my bio on YouTube, and that is johnboywx@gmail.com. So again, thankful for all of you. You guys are awesome. Thank you to all the mods. Thank you for all of the questions. Thank you for just great chat, great everything again tonight, like always. So very thankful and blessed again. Um, but very good. Yes, thank you, Sonia. Thank you for all of your input. Thank you for everything. You guys are awesome. Hope to see you guys again here. Um, Chasing for a Cause says that she also updated hers. Awesome. So everybody, please take a look at Chasing for Causes as well. She's talking about she updated her bio as well. So very great thing, very great stuff. Again, if you are not subscribed to Chasing for a Cause, please subscribe to her channel as well. Because she does, like it seems like that I looked at, looks like a lot of great work with rescue animals and things of that nature. So, um, yes, very thankful. Hopefully to see you guys in here again tomorrow. I do plan on streaming again tomorrow. At some time, I had to kind of play around. Uh, uh, if Brother John goes live tomorrow, um, but again, I also do plan on getting to foray into live weather reporting. So like a Ryan Hall, y'all, or Max Velocity. So I wanted to kind of start digging into that tomorrow to see how that kind of goes. And but I also do want to stream as well tomorrow and teach on another topic. So got some fun things in store for tomorrow. So hope to see you guys all around tomorrow. And again, in my stream, in Brother John's stream, Pastor John's stream as well. So again, you guys are awesome. Look forward to seeing you guys all again tomorrow. Yes, thank you guys so much. God bless all of you. Chasing for a Cause, Sonia, Libby, Debbie, everybody who's in here, everybody who is watching. So just very thankful for all of you. So again, God bless all of you. You guys are great. Very thankful for all of you. So, and like always, be brave,